Okay, so it's 9 a.m. Maybe more people will trickle in, maybe not. Good morning. Um, it's a lovely Saturday. It's way too early. That being said, I am glad you're here to join me. Um, so y'all did pretty good on your quizzes. And the other thing I wanted to talk about was, well, actually, there's a few things. Um, y'all had some really good, interesting things to say about the project management game. I know it's a little bit of a weird kind of thing, uh, but really, a lot of times that's kind of how game development works. It's like herding cats. It really is. But it's also a lot about figuring out whether it's better to have somebody who's expensive and produces the most beautiful things in the world, or somebody who's cheap and maybe doesn't produce as high quality but gets the job done. And it's kind of balancing that. If you kind of liked that idea or kind of thought it was interesting, there's actually on Steam, it's a game company simulator. Oh, what is it called? It's like Game Tycoon or something. I guess I could pull it up and figure it out. Let's see. And it's pretty good as far as something that's like literally um geared towards library, geared towards game development rather than just kind of being a little bit of everything. But where are you at? Game Dev Tycoon. So it works pretty close, and it works like every other Tycoon game out there, if Tycoon games are kind of your thing. But it definitely has some more, kind of has the same kind of project management where you have to hire and you have to figure out who to hire. And it's definitely geared more towards figuring out games, and whether that's you start out as kind of like an indie studio and it goes all the way up to like a AAA studio. So it's fun. If you like these kinds of games, I have a love-hate relationship with these kinds of games. Actually, I have more hours than that. I've probably played it on something else, but yeah. So that's just kind of my little thing about that. Um, the other big thing that I need to talk about is, so next week, next Saturday, if you guys have checked your email, Canvas and ASUS and every other thing that the school uses is going to be down on Saturday. Which means you won't have access to any of this stuff. And that sort of affects us? Kind of. Asterisk mark. Because the other thing that I had to say about next Saturday is I won't be here. So I'm going to pre-record, which isn't going to be much of a lecture anyways, because the entire point for next week, for the next like 2 weeks, is to give you guys lab time to build a love game. So to build a game for you guys. Or for you guys to build a game for me, I guess. So just note that Canvas and everything, and I'll send out another email and I'll send out a bunch of stuff and I'll give you links inside of Discord for that kinds of things. But I am not going to be here. I have a family thing that I have to go to. So, and I will be probably hard to get a hold of for that weekend. Because I'll be gone Saturday, Sunday, and I come back Monday. So, that's a thing. Which I guess kind of works out since Canvas is going to be down anyways. But yeah, there will be a pre-recorded thing. You still will have a quiz. I'll probably leave the quiz open longer. That way, if you guys usually do it right before class, it will still be open. If the quiz does shut and you're like, hey, I can't get into it, or hey, they closed this down earlier than they said they were going to, you know me, just send me an email, just send me a message through Discord, and I can open it back up. That's easy to do. That I can do if you guys really need me. Yeah. Okay, so with that said, are there any questions about Lua? Y'all all tended to do pretty good on your assignments. Everybody got assignments and pretty much had working assignments, so congrats on that. There were still some issues with you guys validating input. So remember, the user is also, while the user is honestly the dumbest creature you'll run into, they're also the most conniving and underhanded. So when you don't actually say, hey, what happens if they press this one button? They're going to press that one button. So always make sure that when you're wanting the player to put a number in, that you validate so that they can only have a number in. So there's still a couple people who haven't turned it in, but yeah, we can go over it. So which one were you having? So like validating the code. So if you looked in here, I actually had one for you guys. Let's see. Are you in this one? Yeah. So you're always free. Anytime I link you, and I linked you my entire REPL, by the way. So you can go and poke in and see all the things that we're doing and all the things that are happening. If you come down here, this one says verify number input. And this is the easiest, well, not really, it's one way to do it. And all it would be is that you do this loop right here. While not num, do print what is your favorite number, num equals toNumber read.io. So the way that this works is that it uses a value that we haven't set yet, so num. And what Lua does is Lua has a special data type and a special value that other programming languages don't really have, insofar as other languages that you've seen, so like Java and C++, would 100% error out at this, because they're like, whoa, 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 num has never been set, we've never seen num, we don't know what num is. But with Lua, we have what's called nil. And as for some of you are like, okay, nil is 0. But it's not. Nil is the absence of anything. Nil is an empty box. It says, yeah, I've said that there's this thing, but I literally don't know what this thing is. I don't know what it feels like, what it does, what it can do. So it's an idea that it is nothing. And because it is nothing, for Lua, it always evaluates to false. So what this does is it says, hey, while there's nothing in num, or while num is false, ask the question that I need to do, so like, enter a number. And then, I want num to finally start to actually evaluate to something. So I want num equal, and this says toNumber, which is going to check or try and force it to be a number. And this is what the user inputs. If the user inputs something here that cannot be switched to a number, that's what this function does, then it's like, okay, let's throw it out, and I'm still nothing. I am still nil. So then, when we come back up to this, like say if they've printed yes, yes cannot be put to a number. So it says, so num is still nil. So we come back to the top, we come say, hey, is num a number? Have we put anything into num? No? Okay, so ask them again. And it just loops and loops and loops. The one important thing, or the one downfall to this loop, is if you ask it multiple times in a row. Which means that somewhere down at the end, like when you are resetting your loop, you have to make sure that you set num back to nil before it hits that loop again. Because once we have something in not num, or something in num, it's going to say, this will automatically be like, hey, yeah, no, num's a num, okay, cool, and it'll fall out of it. But this is kind of the basic, easy way to do it. A few of you found other ways to do it, and, you know, kudos on you. Programming languages, they're just like regular languages. We can say the same thing 8 different times, or 8 different ways. Does that make sense? Okay, so if you have any other further questions about it, let me know. I'm more than happy to go over it again. Again, if you come into here, you have this one. I think as long as you just click the p-sipes up here, it'll take you to absolutely all of my REPLs. And they're actually in folders. But so you guys can actually see any of these things that I've done, or look and see what I've been playing with. So yeah. And you're more than free. That's why I link them all over here. So like I have it here, we'll see it on other assignments and things like that. Because yeah, I get it, because this class is kind of, you know, I throw everything at you on one day and then I throw everything at you on a second day. So I'm willing to bet that even some programmers are left kind of stumbling, especially because Lua is such a weird language. So is Python in general, but because it doesn't feel like a programming language that you're used to yet. And you want it to be more than it actually is. So yeah. So, with that said, let's talk about the Love Engine. Warning! I make bad puns all through this, and you will see them, and you will cringe and wonder why. So the Love Engine. Love is a 2D engine that is built to use Lua. It's that easy. They've got this cute little fish whale thing as kind of their mascot that's all over the place. And do they still have the button down here? No. Okay, so there's a button that will change the whole background for this and make it even more cutesy and sickening. It's wonderful. But this is where you go for all of their wiki, their forums, everything that you need is gonna be here for them. And you can see, you can download Love and Lua if you guys want to, and we'll see why you might want to in a minute, but in the end, everything's gonna have to go onto REPL for me. But the point is that REPL is a good enough place. So, but it does have all of this nice kind of stuff, and it's been supported for a long time now, since Vista. And yeah, it works on Windows, it works on Mac, and it works on Linux, which is wonderful for those of you who need that. And yeah, source can be GitHubbed, and they have a Discord server, and if you're old school and know what an IRC is, they also have an IRC. I have no idea if y'all have any concept of what an IRC is. So, and they're on Twitter. So they're a really lovely community. They tend to be very nice, tend to be pretty helpful. Their wiki is well thought out. As far as wikis go, it looks like a wiki, but they also have categories for you, tutorials, things like that. So they're pretty great. And then, never used Lua before, here's some extra things for you. Yeah, so it's really, really easy. And again, I've told you probably 100 times now, the first thing you ever do in any language is probably going to be Hello World, and they give it to you right away. They actually give it to you on the front page. If we come back here, examples, the very first example is Hello World. So, and see how, again, this looks relatively like what we want it to say. Hey, we want to use the Love Engine, we want to access our graphics, and we want to print the words Hello World at the point 400, 300. We want to make a graphic called whale, and we want to take that graphic from whale.png. And then we want to draw the whale at this point. So everything works. It's relatively, it's a lot closer to English than you're gonna have seen in things like maybe C Sharp or even Blueprints and Unreal. It tends to be more friendly looking and more friendly acting than Scratch. Um, but yeah, it of course that means that it's got some downfalls. Remember, we're going to be using, well, you all are using REPL, so there's a slide in here about REPL. Just go with it. So what I'm going to be looking at, what we're going to be talking about is this one right here. Again, puns. So the problem with looking at it directly inside of here is that it's got a couple YouTube videos attached to it. So I actually have it open for us. So game scripting, Lua, Love Engine. How does it work? Love2d.org, we kind of already talked about that. It's built in Lua, so that's the language that you guys write in, but under the hood, what actually makes it run is C++. And you can access some of that C++ stuff, but it's not really worth it, to be entirely honest. It is relatively super simple, and sometimes that's frustrating because it's so simplified that you can't do things that you maybe want to do that are even bigger. It does have networking, so if you want to network and have multiplayer across computers and things like that, it does do that. It has physics in it. It has a physics engine. You can do particle effects that's already built in for it. And believe it or not, that's like a really big deal, is the fact that it's got a particle system set up. There are tons of user-created libraries and plugins. So just like how, if you guys have used Unity, you can go into the asset store and get people who have made packages to make it work better, or add-ons, Lua's got that too. Love has that too. And some of them are really cool. Some of them make physics work better, some of them make collisions work better, some of them fake 3D, because technically Love is completely 2D, but you can fake it in the same way that things like old school Doom fix it. It has super great licenses. It's like really liberal with what you can and can't do with it. And even better, it's free for commercial use. And you're thinking, I've never heard of the Love Engine. What's actually made in it? Believe it or not, there's actually a lot of games that have been made for it that are on Steam, that even some of them have been ported over to things like the Switch. So it's a versatile thing. Is it a language that everybody's going to automatically choose? No. Is it an engine that everybody's going to choose? No. Especially once you start, those of you who have gone through Unreal or Unity, Unreal and Unity have so much stuff, so many bells and whistles built in for you. This might feel like going a step backwards. So some of you are going to like it, some of you are not. So yeah, like I said, you can trick it into thinking about 3D or pushing it into 3D. But Love itself, the devs and everything are like, whoa, 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 whoa. Maybe try and keep this just 2D because we're not meant to handle that. So there are a bunch of 3D libraries. There are a few 3D libraries that do try and trick it into third dimension, but I haven't really seen. There are examples out there. There are a lot of examples out there, but I haven't really seen good examples that aren't without some crazy bugs. All this said, creating an EXE that plays without you actually having Love installed on your system, it can be more of a hassle than it's worth. But they do have directions on how to do it, so you can do it. So some game examples. The one that you guys may have seen, to be entirely honest, is this one. And y'all are gonna have to tell me if it plays correctly, because I know for the longest time, Discord and YouTube videos hated each other. So you guys may or may not have sound for it, but you probably don't have sound because I don't. Well, maybe, I don't know. But this is the one that you guys, in some way, shape, or form, have probably seen. Okay, you're not gonna let me full screen it, but and if the video actually kind of looks familiar, it's because, yeah, it's built off of an old, actual Mario commercial, but yeah, this was one of those, it was everybody went insane over this thing when it came out. Yeah, it's this idea of, Mario but thinking with portals. And it got really cool because, like it says, additional things. It had multiplayer because Love can do multiplayer. You could make your own courses, you could do all sorts of things because it's just a tile editor. So, yeah, and hats. Of course there were hats. But yeah, so a lot of people, I mean, it's kind of one of those things that you see in internet history, is this whole idea of this specific game, this thinking with portals. And yeah, it was kind of, like I said, everybody kind of went insane when it came out, but nobody really understood that it was built on Love and built on Lua. So yeah, it's kind of cool. Then there's things like Oh My Giraffe, which got released on PC, and I think they ended up like switching it over to a mobile game. And this was 100% drawn inside of Love, at least the original was. So, and then some others. Yes, no? Okay. This one is the one that's probably the most commercial that has been seen, because this one for sure is on Steam, and I think they finally ported, because I know there were plans to port it over to the Switch, but I haven't looked for it. And you're gonna see there's like a pretty good mix of pixel games. I guess I've showed you 3 pixel games. But you don't have to do pixel games. It has enough built into it that pixel games you can use, or you can do like normal kind of graphics. Pixel games just, they currently have that whole aesthetic thing going for them that everybody really loves. And that whole retro feeling that makes you happy. But this one I also suggest. Warlock's Tower is a lot of fun. I like it. I don't remember whether the Twitch stuff still works well. I don't remember whether the API changed over and it did something weird. But yeah, so you can get that one on Steam, you can get that one on Humble. And then we have kind of our basic shoot 'em up Bullet Storm. And again, this one was more built for mobile, if I remember right, but that it can be played on PC and stuff like that. So yeah, you can build, whatever you want. Love in Lua it's versatile. It'll let you do a 2D game. Will it let you do a 2D game and make a 2D game as easily as, say, Unity? Maybe or maybe not. It depends on what works better for you. Because all of this is going to be programmatic, so all of this is going to be in code, and y'all are all going, no, not more code. It may or may not work better for you. But I do want to say that it tends to be more straightforward as far as your development goes, because you take out all the extra stuff and you just do it via code. So yeah. So other examples, if you come to this link right here, it's gonna open in Internet Explorer, isn't it? No, it did. Yay! Last night it had a huge issue. There are all sorts of other examples, and you can click on them. They'll take you. Some of them will be free, and you can play on them. Some of them are just like demos. Yeah, there's Dr. Cat, which is at Giga Pudding, which is terrifying. So yeah, there's all sorts of different things, and like I said, you can build whatever you want. Some of them are pixels, some of them are vectors, some of them are kind of a weird mix. Yeah, and so this isn't all of the games, but it's definitely a chunk of what they like to kind of pimp out as their games. So yeah, and then like Going Home, which was another one, which was, I don't know if they have it in here. But yeah, so you can find all sorts of games that were built inside of Love with Lua, and it's kind of cool. It's kind of cool. It's fun to look at games that have been released on things like Steam and other places, and yeah. So know that we're actually using something that could be used for development and is used for development. Over here. So, getting started. No, we already done this. We use REPL. So, to start a new kind of project, again, you're going to scroll down. It's in my favorites because I already use it, but you're just going to scroll down, or you can come and do the type and type it up here and start doing love, and it'll do it. And name it. Either keep the weird name, because you can always change the name, or name it whatever you want to name it, and then you just create REPL. And just like how we did with Lua, you're going to notice that we're in main. It works like Lua, because it is Lua. And there are a few things that, of course, they're going to want, but basically it's a Lua file. So if you are going to use the downloaded version, you have to create a folder first and name it whatever you want the game to be, and then you create the file named main.lua inside of it. So that's if you download it. If we're just using REPL, it's main.lua is auto included. Life is nice. When it comes to distributing, so like remember when I said making an exe can be a pain in the butt? You kind of have to bundle and fuse it together with the Love Player, and they do have a whole walkthrough, but I wanted to make note that like that's kind of how it works, and you can't do it directly from REPL, so you will have to download Love and Lua and then download your files if you're wanting to make EXEs. I don't require you to make EXEs as a side note, but if you're wanting to, if you make something cool and you want to share it with friends, you can still share it through REPL, but again, I'll show you kind of why REPL kind of gets a downfall when it comes to these games. But yeah. So, there are 6 lines of code in asterisk mark every game. And the reason why there's an asterisk mark there is because you can technically have things that leave out update or leave out draw. It depends on what you're doing. I mean, they can also leave out one of these, but these are basically the 3 that you're going to need to actually make up a game. So, and just like with other things, let's come back over here. We talked about the last time what functions were, and again, REPL will try and give you some examples, so if you click, it used to be in here. Why it doesn't have it there anymore, I don't know. So, if we just start typing in function, sometimes the first one will pop up and sometimes it won't. Love.load, end, and we know we're going to fill stuff in. Function love.update, end function love.draw. So, what do these 3 things do? And if we run it, we can see if I actually, killed anything. I shouldn't have. It's too early for me to kill anything. Okay, cool. So, and we talked about this. This is the first time that you guys are going to actually see that there's a visual component to this. So you have the console, so you can print to your console, just like the way that we use a debug log inside of Unity, for those of you who have used Unity, or anything else where you print to the console. If you guys have taken Java, where it gives you use a GUI, I guess C++ you could too. You can print to the console where the player will never see it, but you can also print to the screen. So it's important when you're making changes to code to try and press that stop button. Unlike with like Unity, where as soon as you make a change while it's playing, it will, it doesn't save that change. It does save the change here, but it's good practice to not have it running while you're making changes, because it can cause problems elsewhere. So, what do these things do? Well, load is where you set everything up. So that's where you save your starting variables, that's where you initialize things, that's like the first steps you want to make. Update fires every frame. and says, what do we need to update? What values do we need to change? What am I looking at? Am I looking for key presses? Am I doing that kind of stuff? And then draw, literally, what do I need to draw? What do I need to make the screen look like? Because what Love does is that it basically deletes the entire screen, and then it asks for you to draw that screen again. So we can't see it doing that, but that's what it does. So you've got to actually tell it every frame to draw this thing here, draw this thing here, draw this thing here. And that's kind of the 3. And those of you who will go out and find tutorials, and I know you will see that sometimes love or draw comes before update, and sometimes update comes after draw, or sometimes they kind of mix them around, and that's fine. One of the things that I didn't mention when we talked about Lua, but will become super important with Love, is that the order they are on the screen, so the order, this is how they will function. So whereas inside of something like Java or C++, you might be able to put a function down here and then call it up here, in Lua and in Love, the functions have to go. So if I'm gonna talk to a function, so if I'm gonna add another function like here, like if I wanted to say function Joe Bob end. So this is fine, and I could access Joe Bob here, Joe Bob, without a problem. But if I try and access it here, Joe Bob, and we run it, it may not do anything because we don't have anything in things. We're gonna see. Okay, so it actually will run it right now because they're empty. But the whole point is that technically it can't be accessed here, or it can't do things here because this doesn't exist yet. This is a nil. This is kind of it's a place in memory, but it doesn't do anything. So, yeah. So it's going to be in order. You want things to be in order. And sometimes that can get more tedious than it needs to be, because you got to figure out where functions have to go to make sure that they can be called. Just remember, it has to come before the call. So you have to make it before it can be called. Rather than with Java and C++, where you can kind of put your functions wherever you want to put them. With Love, it's literally that order. Or with Lua, it's literally that order. So you want to access the variables in that newly created function. Variables have to be put in load, and then so a lot of times you'll see stuff in load, and then you'll see a bunch of functions, and then you'll see love.update. That doesn't mean that you have to use extra functions. If functions don't make sense to you, if you don't understand how they work, or they don't really kind of jive with you, you don't have to worry about them. You can 100% do things with just these 3 things. So, like I said, love.load, it loads the assets. Love.update, it basically, yeah, it does its thing. And function love.draw, it makes things appear on the screen. So, in this example, I have a DT here. And you can either have the DT there or you don't have to. And the DT stands for delta time. Of course, it's best to have the DT there because that means that you're checking over time rather than on frames. And we'll see in a minute. If you don't know why that's a thing, we'll talk about that in a couple of seconds. So, making something appear, all you have to do is tell it to do something inside of draw. So, we can do that by saying love, and again, remember, because this doesn't automatically tap for you, love.graphics, and sometimes it kind of has like that whole IntelliSense that will fill for you, sometimes it won't. That's one of the nice things about having the actual Love engine and a Lua compiler, but it's up to you. So all this says is, hey, print this word set at 300 by 400. And if we run it, and I haven't killed something, and if REPL has decided that it wants to work today, there we go. We have hello world down there. I know it's super tiny, and yes, you can manipulate the size of your text and everything, but it's there. Now, something that you may have noticed, or maybe haven't noticed, and we talked about this when we were talking about learning a new engine and learning a new language. When we talk about where 0, 0 is, like where is the origin point, because you think of generally something being split into quads and 0, 0's at the center. Those of you who are coming from Unity and level design should remember that 0, 0 is this bottom corner, top corner, whatever. Yeah, it's the bottom corner. Inside of... Now I don't remember where it is in Unity. Wow, okay, and I just taught that lesson. Yeah, so inside of Lua and Love, or inside of Love, not really inside of Lua, inside of Love, 0, 0 is this top corner right here. So this is 0, 0. This down here is going to be 0, 600. This is going to be 800, 0. This is going to be 800, 600. Yeah. So that's something to kind of remember. Because that means that if we want to like go up, we have to do a negative. If we want to go down, we go positive. It's a little bit of weird. Yeah, 0, 0 is down at the bottom for a lot of engines, but we're going to see, I think with both this and Pygame, it's up in this top corner. So, that's a thing. It's kind of an annoying thing. So what this says, yeah, again, take the graphics functions from Love, use the print function, print the words hello world, and print them at this number and this number. That's all it does. So common lines that we find in load. So that's that first one. This is where you set things like your image, and if we have a graphic, we might do image name equals, and then again, we're accessing the graphics package of Love, new image, and the image name. What this does, and the only thing this does, is it loads or it primes the image to be used by Love. So for an example of that, if we come over to, does this one have it? That one should have it. This one should have a penguin in it. If we come over to here, we have this thing that says image equals love.graphics.newImagePenguin. All this means is that I can now call penguin. This doesn't actually draw a penguin anywhere. It just makes it a variable that we can then use. Down in draw, you can see I actually call it, and this is a little bit more extreme than what you're going to have to do in general. This is because I needed to scale the image. But what this says is love.graphics.draw. So take the graphics package of Love, and we want to draw something. What do we want to draw? We want to draw image, which is the variable that we created up here. We want to draw it. This X is kind of it's meant to be wherever we want to put it, and that's for animation. The reason why it's for animation purposes. So it starts at 0, and then like the next one it'll move and it'll move and it'll move. So at whatever X is, at Y, so 100. This has to do with a few things that we'll get into a little bit later. And then this is saying, hey, I do want to scale the image. So I think this one's rotation. But I do want to scale the image, and so here's the scale that I want to scale the image. Generally, you don't really need these last three things. These last three things are optional. It's an overloaded function. If that makes any sense to you, cool. If it doesn't, don't worry about it. So if we run it, and it decides to do its thing, we see we have our penguin moving. And you can kind of already see some of the issues with with how it's kind of choppy and weird. And that's because REPL is having to, it's a virtual machine, so it's basically having to process this in 8 different ways before you actually get to do anything with it. Yeah. So, but that's how that's kind of how those two work together. So you call it, you say, hey, I want this thing to exist. So you have to really think and really plan. I want to think that, or I want this thing to exist. Now I want to draw this thing. And technically, in update, I want to move this thing. So that, no, go away OneNote. Why are you still on the board down there? Okay, so love.graphics set new font 12. This changes the size. By default, I think it's set at 12. But yeah. Love.graphics.set color 000. It sets the default color for font. This sets a default color. This can be called anywhere. So you're going to call it, you're going to see that I call it a lot of times inside a draw. And you have to call it before each thing. Otherwise, when it goes back through, it will change over to whatever color was the last color that was mentioned. Setting the color for graphics, especially for text, right here, it's going to look a little weird because right here we have 255, 255, 255. So, and that's kind of probably the numbers that you're used to. Inside of set color, I think 255s still work, but the one that they prefer is 0 to 1s. So 1 being the full color, 0 being the lack of color. So if you wanted something to be pure red, it would be 100, pure green. It would be 010, etc., etc. So just note that that works a little bit. It can work a little bit weird, and they mix and match it, which does not. Mixing and matching it is not good. It's not a good thing. But yeah. So that being said, background color works on the 255s. So love.draw. Like I said, drawing an image, so just drawing an image can be really easy as long as it's to the scale you want it to be. And it's love.graphics, so we take the graphics package of love and we want to draw something. What do we want to draw? We put the image variable in, and then we put the X and the Y. So, love.graphics.print. Again, we looked at this one. This is how we did Hello World. And then love.graphics.setColor, RGB. Again, you often call this before the color changes, and we talked about that. So, other usable functions that are outside of those 3 functions that we looked at, outside of load, update, and draw. We've got mouse pressed and mouse released, which, again, if you press it down, we trigger mouse pressed. If we release it, we trigger mouse released. Key pressed, key released. So these should look pretty similar to things that you've seen in other languages or in other engines if you guys have been through other engine courses already. So Unreal, Scratch, Unity. Focus. This checks to see if the window is in focus. Or is in focus. And again, you're not going to have to worry about this if you're using REPL. And quit is not going to be functional if you're using REPL. The other big issue with REPL is that REPL cannot process sound. So you can put all the beautiful instrumentation and background music and cool sound effects as you want. You're never going to hear it inside a REPL. It won't error out. You just can't hear it inside a REPL. So, let me close OneNote before it does its thing. If we look here, I actually have keys. So on key released, so this is how this works. Function, remind me, if I don't make things big enough, remind me, because I know it's a pain in the butt. So function love.keyReleasedKey. So it looks exactly like what we talked about. What we're doing is we're accessing love, and then we're accessing its key released function, and we're looking for a key as the parameter. So we're looking for something to be put inside of here. If key is equal to T, then text, you press T. Else, if key is equal to A, you pressed A. And remember, because it is Lua, we can have single quotation marks, or we can have double quotation marks, and it's not going to matter one way or the other. And then if you press any other key, other things happen. So when we run it, I don't actually know how this is going to work. It should be fine. And we press keys. You pressed A. You pressed T. Other key press. So that's how that works, and the other ones work like that too. And again, their wiki is really good about explaining all this stuff, and explaining it in way more detail. Basically, think of what I'm trying to teach you as a really slow quick start guide, for lack of a better kind of get up. And if you start with getting started, it'll walk you through, but you can also, like, if you actually want to, like, look at something, you can come over to there and search for it, and so, like, we could look up, the search bar used to be up here and now it's not up there. Can do key pressed. So, and you can look at it, an event for key pressed, or we can look at other things like that. So, key. Oh, so you know, you can look up whatever you need to look up, and they break it down in further things. So, like, if we were to look at love.image. It'll give you all the functions, so all the constructors you can use, all the functions that can be used. So this idea that you can actually get height of your images, things like that. So sometimes it's a little unwieldy to find everything, but yeah, you can actually even love.keyboard. There we go. So key pressed, key released. So if we look at key pressed, it'll talk to you about how you can do it, what you want to do. And it actually includes the things that have been removed. So if you guys do find tutorials, and I assume that that's probably what you're going to do for your games, you might run into some things that are deprecated or have been removed. And so this will tell you all the things that have been removed and then what they've been replaced with. So again, you don't need all three of these parameters because it can be overwritten. So yeah, but this will give you all the nitty-gritty in the background. Sometimes it talks more about things than you need. So love.mouse, mouse pressed, mouse released, mouse moved, wheel. So it's got everything that you could possibly need inside of here. And these are the basic documentation sets. Audio you'll never see, font, graphics. And like I said, so some of the pages will have a lot more information than others. And you can see how much graphics actually has. So, and there's enumerators for those who like those. They exist. So yeah. Okay. So, that's the end of that one. We're going to go back into the web browser nowadays. Now that we've kind of set everything up, hopefully you guys have kind of a basic. I don't know if any of you are following along or if you're just sleeping, as far as coding and things like that. generally the way that this class works is I present one thing, we do a little project, then we present the next thing, we do a little project. But with this class, it's maybe not as easy to do that, much the fact that I'm sure because it is almost 10 o'clock, but 9 a.m., you guys all want to be sleeping and me to go through this stuff faster. So, yeah, there's a difference when you're like forced to be somewhere listening to a lecture and doing stuff versus being at home, I'm sure somewhere comfortable. So, yeah. So drawing with love. Aww. Again, I told you I'm bad and punny. So, yeah. Again, when in doubt, ask the wiki. I do suggest looking at the wiki before like typing it in and going to Stack Overflow and something like that, because Stack Overflow a lot of times will have the antiquated way of doing it that then won't work anyways. So, so if you can, and especially if you can find it on the wiki and you can figure out how to use the wiki, then like your life is golden because you're always going to be able to find that. We already talked about this. Love's coordinate system is rooted in the upper left corner of the screen, so up here. So that's 0, 0. The x-axis is horizontal, so it's a hot dog. And then the y-axis is vertical. I guess it's also a hot dog. It's a hamburger. So that should be, it might get a little bit, you might kind of have to work with that because a lot of people get a little confused when they're like trying to make things move upwards and they're like, but wait a minute, I want to move upwards, so should I be making the number bigger? And the reality is that you're trying to make that number smaller. And y'all will have an assignment that kind of works with that, so yeah. Because of the way that this all works, it can cause issues when you try to render 1 pixel wide lines. So their suggestion, I haven't run into the issue, to be entirely honest, but their suggestion is to change the coordinate system, which is a pain in the butt, to the center, or to make it like do whatever you want and then add like half a pixel in. Again, I haven't really seen the problem, but if you do, that's their solution. So angles. Angles are important if you're wanting to do things like curves or arcs or things like that. And for those of you who are not math savvy, this is going to make absolutely no sense because you've probably maybe seen it once in your life and it gives you cold sweats and you don't want to think about it. Angles are expressed in radians rather than degrees. So when we think about it, we think about a 90-degree angle, a 45-degree angle. We think about those things. But when you're in math land, you generally tend to think in radians because it's more precise. So we look at a circle is 0 to 2 pi. So an entire circle is 2 pi, which is around 6.28. So you think of in radians. So 180 degrees would be 3.14 would be pi, whereas 45 degrees would be half of that, etc., etc. So radians. Yep. The value increases clockwise from the top corner, and a lot of times this feels backwards. So just note that these work a little weird. I'm going to ask you to draw circles. I don't ask you to draw anything that's going to require you to use this. Because spoiler alert, you guys are going to be drawing things today. And animating things. So yeah. Points are great. They're easy. If you just want like a little star point, it's love.graphics.point where you need it to be. So this is actually built in where it has that offset, that 0.5 offset, and it's made so that it like puts it at the center. It's kind of cool. They are not affected by love.graphics.scale. Love.graphics.scale can scale everything and make things wider and thicker, etc., etc. But this doesn't get affected by that. That being said, you can change the point style and you can change the point size, which will make it bigger or smaller. Now, what happens if you say want a starry background that is a bunch of different stars or a bunch of different points? You don't have to write this over and over and over again. Instead, you use either this or this. Love.graphics.points and then x1, y1, x2, y2, etc., etc. So for all of your points. Or you can call a table. You know, this guy. And the way that a points table works is that you always have to have these 4 values at the end. So it's x, y, RGBA. X, Y, yeah. So you can do X, Y, 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 so on and so forth, RGBA. But yeah, so that's kind of, that's that thing. This is easier, to be entirely honest. But it will take this if you want. Yeah. So, drawing lines. Love.graphic.line, x1 to y1 to x2 to y2 to x3 to etc, etc, etc. You can also use a table of points, which are just points. So it can be a setup of, and remember, tables are basically our arrays, so yeah, that's all that is. So it can take a table, or you can put all the things in that you want to put in. It's up to you how you want to do it. Arcs, circles, ellipses, and rectangles. They have their own kind of function. Love.graphics.arc. The mode. So mode is whether you want something to be filled or whether you want it to just be the outline. X and Y. So for this, it's going to be X and Y tends to be signal the top left corner. The radius, angle 1, angle 2, and segments. Again, I'm not going to ask you to draw arcs. You don't need to draw arcs. Unless your game is going to require you to draw arcs. You don't have to understand that. Circle. X, Y, and mode. And you can play around with this because what you see is that depending on the language, this is another interesting thing. Depending on the language depends on whether circles get drawn at the center point or at the if X and Y it denotes the center point or if it denotes the edge. So if we do love.graphics, let me make sure. No. Yeah, love.graphics is a circle. I think it's Phil. Sorry, I've been running between like 4 different languages and sometimes they kind of all run together. So we can see, press stop, run it. And if I've done nothing wrong, I have done something wrong. Bad argument to number 4. So, and this is where you're going to see 11. Oh, radius. Yeah, that's really helpful. Yes, type. There we go. So, what it is, where it's at, and the radius. And like I said, depending on... Circles tend to work differently than any other thing. So as you can see, that's the center point. So if you want to figure out where it's going to be, you need to take your radius and yeah, you have to do some math. So in this case, we know that we would want this to be over 25 and to get it up in that top corner. if I'm thinking straight at 10 o'clock in the morning. Yeah. So you want it to be like that. So just remember and play with these. And that's going to be kind of this thing. Today is about you guys getting in and playing in love. So, ellipses. So if you want it to be a perfect circle, it's going to be this way. If you want it to be an ellipse, it's going to literally look like this. Just instead, you're going to do radius y at the end. So you just add another one and it'll call ellipse. And then rectangle, again, mode, x, y, width, and height. Nice and easy. Now, polygons. Say you want to draw, I don't know, a pentagon or a triangle or something else. A nonogram, whatever you want to do. You use polygon. If you're using fill as your mode, so if you want it to be a solid shape, it needs to be a convex shape, which means, it needs to be kind of all filled in. Otherwise, some funky things can happen. And to do this, it's relatively easy. You do love.graphics.polygon, so the same thing we've been seeing. You do your mode, and then it's your vertices. In the same way, you can have a vertices table. So you can have, maybe you set up your vertices at the beginning, and I'll show you some examples. And you can just call the table. So quads, triangles are deprecated. They may be back to working. They weren't, I think, last semester, but there was talk about them putting triangle back in. But you just use polygon for quads and triangle. And they're relatively easy to use. So, for example, let's look at something that's not terrifying. Simplified rocket. For example, when it comes to drawing a polygon, and remember, spaces don't count. This is specifically so that I have all my y values in one kind of column and I have all my x values in a second column. So this is to draw, it's kind of a pentagon. It's a rocket shape, like a rocket body. So we have love.graphics.polygon. We want it to be fill. And then the first coordinate. And again, these could be numbers. The reason why these are variables is because I have the variables all set at the top so that I know what I want, and it means that I can manipulate one of the values to actually animate it, because that's what this assignment, what your final assignment today will be to animate something. So it's an x value, a y value, an x value, a y value, and these are the points that connect together. So that and then we've got a flame, which is a triangle. And again, you guys have this, I've given it to you to look at. Yeah, so don't think I'm just showing you something that you could never see again. It's in here, I promise. So it's just that shape, and that's a triangle. This is like the absolute most simplified version of your final project. Or not your final project, but the second project that you're doing today. And you can see how it's doing some little funky graphic things. And that's all because it's doing it inside of REPL. If you did it inside of like the Love and Lua on your desktop, it does it a little bit cleaner. Yeah, so, and again, if you want to kind of find out about this kind of stuff, if we go to Polygon, it'll talk to you about draw mode, and if you click draw mode, you can do fill, you can do line. It's pretty simple. It's, I hope it's pretty simple. Does this make sense to everybody? At least basic kind of sense? Okay, I'll take silence as sleeping, or that, yeah, we're good. So, you have 2 assignments for today. And you can kind of work them together, which is gonna be up to you how much you want to do. The first one is just a drawing. It needs to have a line, a point, a polygon, an ellipse or a circle, and a rectangle. And this is where, when I was talking about at the beginning of class, at the very first day, I was like, yeah, having some graph paper might be nice, or something that you can plot points on. For this assignment, the next assignment that we're doing today, and then you're going to have a similar one inside of Python with Pygame or Pixel. This is where graph paper helps, because you need to draw me something. Now, the second assignment for today also has you drawing something. It has you drawing the rocket. If you want to kind of combine them so that you draw the rocket as well as use that same rocket for your animation, be my guest. What you may also do is figure out how to draw a space scene for the background, and do the space scene for this one, and then your rocket for the animation one. So, it is up to you. You can draw whatever you want. This is kind of my example. I've done it in Pygame, and I've done it in Lua, or in Love. Remember that you have to figure out what goes in front and what goes behind, because the order you put things in will be the order that they show up. You want to cut a chunk out of a circle to make a moon. You got to make sure to draw the white first, and then draw the black on top of it. So, it just has to have these things. My suggestions: a snowman, a face, a take on your favorite pixelated character, night sky. Last semester, somebody drew a Domo. Somebody drew Hello Kitty. We had a few different animals. We had somebody drew Pikachu. Somebody did do a background for their rocket. There were a few people who did their rockets. Somebody drew a Keyblade. So it's up to you what you want to do. This is 100%, or, go find something somewhere that you find online. You're like, this is a cool picture that'll look fine pixelated. It meets all these things. Cool. So, I need a line, a point, a polygon, an ellipse or a circle, a rectangle, and that's it. So, just make it something artistic. I don't want you to just, shove those on a page and be like, it's modern art. That's not what I mean. I want you to actually make something. And I'm not expecting it to be this. Please, anytime I give you an example that seems like it's overblown, it's because it is. Honestly, generally, it's because I've played around with this for way too long and had fun, and then got lost down a rabbit hole, and something that was supposed to take 30 minutes then took 6 hours. We all have those things. It's like a video game. You say you're going to play the video game for an hour, and then you're going to get off and do homework, and the next thing you know, it's the next morning and the assignment's already due. I get it. So, what you're going to do with this is you're going to post a screenshot of your drawing and a link to your REPL. And then you're going to look and you're going to talk to other people. Comment on 2 people's drawings. There are fewer of you, and if you've noticed, there are fewer of you. We did have one person who had to drop the class. Not willingly, but he had to drop the class for reasons. So, there are fewer of you. Okay, so once you have drawing down, the next thing you want to do, of course, is to make things move. Now, making things move is basically the same way that we've been doing the whole drawing. You just have to make sure, like I said, inside of here, You want to have things where you have variables so that you can change the variable, so you can change where y is on this thing, or where you can update things. So in this case, I have variables for the y, so the bottom corner. I have the x center so that I could figure out where I wanted things to be. And these are cool because this right here, love.graphics get height, this gets the height of your window. And this gets the width of your window, which means that I can 100% put this one in the center. And this one, the reason why it has a -25 here is because REPL has a visual glitch. If you draw something at zeros, like all the way down at the bottom, it doesn't show. Like it gets cut off. So you have to kind of manipulate it to do its thing. So I have my rocket half width, so that's how half of how big I want it to be, so that I know where that center point is, and I can put it 25 behind and 25 in front. Life is all good. I have the rocket height. I have the start speed. Because I'm animating it going up and then coming back down, I need to know when it can go up and when it's going down, so I have that. And then I have flame issues. So, and all I do inside of update is I say, hey, if we're going up, then change where rocket corner Y is. And it says, okay, cool, I'll change where rocket corner Y is, and I'll just keep shooting everything up. And up and up and up, because everything down inside a draw is built on this whole idea of where rocket Y is. Another way to see it, probably an easier way to see it, is this idea that we just want this penguin to move across the screen. So all we need to do is manipulate the X value. We need to tell it, hey, move your X value and move it at such a time. So down here we say, if X is greater than 800, so if it's gone over this edge, or it's equal to the edge, then move to the right equals false. So we don't want it to move any further right, we want to start moving it to the left. So all we do is say, hey, X value, we want to add 100 pixels times delta time for each frame update. And so that's how we get it moving to the right. And then to get it moving to the left, we say we want to subtract 100 so that it starts going that way. So we're just manipulating the one value where we tell it to draw. So like we said, hey, and you remember, it clears between frames. So literally what this is doing is it creates a black screen, then it goes, okay, I need to print the text at 0, 0. Okay, where do I need to print the image this time? So it looks at this and it prints it. Then it does a black screen. Then it does, okay, I need to print the text here. Where do I need to print the image? That's how this works. So with that said, let's look at the long, wordy PowerPoint. No, it's not that wordy. It's only 6 pages. So setting up a moving rectangle. This is just what we've talked about. It's this idea that you want to manipulate one of the values so that it moves. Or maybe you want to manipulate both of the values so that it moves in a diagonal. So in that case, you would need both X and Y to be a variable. So in this case, we do, hey, function love.load. We're making a rectangle and we want it to move. Function love.load, X equals 100. So this means that we want this variable, this X variable, the original point for your rectangle to be drawn, we want it to be at 100. And then in love.draw, we're going to draw the rectangle. We want it to just be the line, so we just want it to be the outline. We want to draw the X value, so the X point of it, we want it to be at X. And then we want it to be at 50y. And we want it to be 200 wide by 150 tall. So, come over here. We have x equals 100. And then we can come down here and we say love.graphics.rectangle line x 200 150 100 whatever. I know those aren't the numbers that are over in the other document, but that's what it is. So now when we press stop, and it thinks about stopping and crashes because that's what it's gonna do. Reload. How much did you just delete? So every now and then REPL will have a glitch like this where it just kind of locks you out of everything. So just note that this is a thing that happens. So x equals 100, and you can save if you're inside of here and you press Control S, it will save the document. You can also come, I think it's in, no, it's not in settings. In one of these guys, you can also just, like, manually save, but Control S is your friend. Love.graphics.rectangle line. So why do we use rectangle over polygon? It doesn't really matter. You can use either, but this is faster to write. And again, one of the downsides of this is that you don't get, if you're used to other languages, you get like red squigglies under things if you've written something wrong. This you won't get anything until you actually try to play it. So that's one of the things, and you guys have probably already learned that with Lua when you wrote your Lua projects. So you see we have our nice little rectangle. And it's at X, which we've set up here as 100. And 200. So it's 200 over. So it's cool. So, now that we've got that guy, the next thing we've got to do is actually manipulate the X value so that it's moving. So in update, the simplest way to do this is X equals X plus whatever. 5 may be too small. I guess we'll see. So inside of update, we want to say, hey, what do I want to do every frame? Every frame, I want to manipulate X so that X is 5 pixels bigger, or 5 pixels further to the right. So then you can see, when we run it, it should do its thing. So there we go. We had this thing completely, completely go off the screen. So 5 wasn't too fast. Sometimes you're gonna notice that some things will make things faster than others. Okay, phone. That's nice to know. So again, it just yeets itself off the edge. So it's that simple. I mean, I hope that that's simple. I hope that that makes some sense. It's this idea that you want to manipulate a value. And that that's all animation is. At its very, very, very base, that's all it is. But, there's always a but, right? This isn't exactly what you need to do. And we've already seen that I add, another thing into this. But time is not our friend. Time is the enemy of all. And RNG is its greatest, best ally. So FPS, two systems with the same setups, the same everything, can end up running at different frames, different frame rates. And that's just for a whole number of different things that work on the underside. So the point is that we got to make a way that we know that the frame rate is going to be similar or steady. And the way we do that is by kind of tricking it by using delta time. So basically we say, hey, how much time has passed between this and the previous frame? Okay, cool. Multiply whatever our number is by that number so that we know for sure we have a steady movement. So we're still only firing we're still only firing our frames every X seconds, or every, multiples of parts of seconds. But because we have that multiplication of delta time, it looks like we're firing it at a steady movement. So instead, we kind of fix it a little bit further. So we come in and we have to tell update that we want to use delta time. So we have to input it here. And that's all we have to do. It'll understand that. That's fine. And then we just multiply by delta time. Now again, if you guys go and find tutorials on how to make certain games in Love and Lua, they're going to do this slightly different. Some of them will do this slightly different. This is the easiest way to do it. And I don't understand some of the other ways that they decide to do it, because I would rather write DT than actually accessing the OS and the delta time stuff. So you're going to see that it does make this move slower. So this is where, you've got to play with it. And this is because it's literally multiplying by parts of a second, so that number gets infinitesimally smaller. Like what we could do is we can actually, if you wanted to see how small DT is, we can say print DT. And start. We're gonna actually do our thing. And you can see, if we stop this, these are very tiny numbers. And we're multiplying this value by this tiny number. So what you may do is multiply it again by 100 to get it back up. But it's up to you how you want to do it. But so these are very small numbers. So like if we multiplied it by 100, and even that might not be... that might be close to enough to get it closer. So you kind of saw it went a little bit faster, but it's also going to start at 500 rather than, where it needs to be. So my suggestion is always going to be to just use DT and then manipulate this to a faster speed. So remember, these numbers are very small. And you can see, none of them are the same. So my frame rate isn't steady. And that just has to do with everything else that's happening. And it's very rare for you to have a super steady frame rate. Like, yeah, these are pretty close. Like 0.0040 blah 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 blah, 0.0044. Like, those are super close. But then we get things like 0.03, which is definitely different than 0.003, which is different than 0.008, And you probably have seen this, again, if you guys have taken Unity or Unreal, you've talked about frame rate a little bit. Yeah, things get a little weird. Frame rate, yo. And if you ever want to clear out this panel, if you just click this button right here, it'll clear the panel out. If you want to search something that's inside of your console, you can use the find button. So yeah, so we might say, hey, I know that that's weird, so why don't we do this up at 50 instead? That might make it better. Because the other thing to remember is that we're using PEMDAS, or sort of PEMDAS. So your order of operation is important. Multiplication and division will always come before addition and subtraction. That's the one to remember. Parentheses come before those, exponents come before that. So Yeah. That's kind of my thing on that. Now, if you want to move with the keys, in update you can say if love.keyboard is down, then do whatever you're needing to do. And so the key name here would be like T or space or enter. Following the mouse gets a little... it can get pretty crazy. I'm going to leave this here for you if you really want to follow it, but it gets a little crazy. So, with that said, what I want to talk about, the other thing that you have to do is you have to do a rocket. And this is what I'm talking about when I'm talking about, yeah, you've got a drawing and you've got animation, and they're two separate things. So, I've shown you what the simplified rocket is. Then we have kind of the medium rocket, and I'm not expecting you... the simplified rocket is about the base level of what I want you to do for the animation portion. So, the medium rocket, it's a rocket that goes up. The flame only shows when going up and is off. This a version with a flame that grows and speed acceleration. You don't have to have acceleration. The flame doesn't have to grow. It's just something nice to have. And you can see it's starting to slow down. I promise it doesn't. It does get all the way down to the bottom. But yeah, so it slows down. So, and these are all provided for you to look at. Again, I would like you to try and do this on your own first. But they are there for you. Oh, come on. You were moving faster last night. But so it's going to hit the bottom. And then it goes back up. And so that's what you're going to do. So you got to figure out how you're turning the flame on and off. And you got to figure out how you want to get it so that the flame only shows when it's got enough room to show. When it's coming up this way. And again, on top of doing all the drawing. Again, I have these for you. You can look at these. If you are so lost and you can't think it out, remember to pseudocode. Remember to say, okay, so how would I actually do this if I was to write it in plain English? And that can help you develop a plan for how you want to write it. And if you're wanting to talk about above and beyond, I went a little crazy. And it says I do not expect yours to look like this. We have this one which has variable flames. It's got like a super awesome body. It does its thing. If you want to do something like this, be my guest. But it is 100% not required for this assignment. So, with that said, however, you are going to share these, and you are going to share your drawings. So everybody will see what kind of rocket you made, and everybody will see what kind of drawing you made. Link the REPL and comment on 2 classmates' posts. Okay. Does drawing and animation sort of kind of make sense? Or enough sense that you think once you actually start playing with it, you're going to be good? Okay. So there's one other thing that I wanted to go through today, and it will probably take a good chunk. But it's kind of up to y'all whether you want us to do this one or whether you want to look at it on your own. Whether what I've already told you guys is already having your head swim and you're having a hard time thinking of things. because what this does is, and again, it's a tutorial, so it walks you through everything. But it's a cursor that or eyeballs that follow a cursor. And it does get kind of in depth insofar as it does some cosine and sine math. But it's one of those, it's more advanced, and you're not going to be able to understand everything, especially if you're not a math person. But it does give you a good idea of what can be done. Or if this one seems like, whoa, I don't want to do that, like that seems way too kind of in depth, we could do one of the other ones. But it's up to you whether you guys want to walk through, like the googly eyes I like to walk through because it's kind of a cool example. But it's up to you guys. Do we want to walk through that one? So, it could be. Let's talk about the game. Let's do that first, actually, while I'm thinking about it. While you mention it. So, you do have a major project. You are making a love game, and as of like this class, you can get started. I basically taught you what you need to know. Not really, right? Your game should be simple. Think of really, really simplified games. I'm not asking you to do anything amazing or crazy, or like if you've taken Unity or Unreal, I'm not asking you to have start pages and buttons and UIs. And you want to make a cookie clicker game, you can make a cookie clicker game. We've talked about how you click things, we've talked about how you move things, you've talked about those kinds of things. And what it says, create a game in love. That's it. What am I going to grade on? Show some effort. Ooh. Yeah, that's literally all there is to it. Some tips: pick a classic arcade game. In week 1, there's a resource folder or a resource kind of page file thing that has where you can get all sorts of free pixels and sprites and things like that. Again, if you come into my REPL, I've got a few game examples. So Googly Woogly, this is what the googly eye thing does, I think. If I remember right, this one's fully done out. I suggest that this is probably more complex than what your game needs to be. So yeah. So that's what the googly eye assignment or the googly eye tutorial does. That's all it does. So, but some other examples. This is a good example of how REPL is can be awful. We'll go with it that way. Okay, so this is just controlled with the keys. But you guys can't see, but I'm like having to hold the key down for it to do anything. But if you're going to do a maze like this, one, collision can be a pain in the butt, but you're literally going to say, hey, if you enter this thing's area, then I want you to stop. That's all you're going to do for collision. It's not anything crazy, it's not anything amazing. And then I have a start again thing, but you definitely don't have to. If we come over here, we can see how I have the maze set up. This may look like gobbledygook to some of you, but each of these corresponds to a thing. So if we run it, We can see S is start and F is finish. So those are the blocks where you start and the point where you end. Anything that's a Y is the basic floor tile, and anything that's an X is your crates. And all it does is it creates the maze using these things. So we say maze graph, it's a function. So function maze graph, and we take a parameter Y. We take a parameter X, we take a parameter S, and we take a parameter F. So it says, hey, what tile do you want at these different places? So I say maze with image, maze graph. We want the ground tile to be Y. We want the wall tile to be X. We want the start tile to be start, and we want the finish tile to be finish. And then we have a timer. Game over. I have multiple things for the player so that he can move left, right, and etc., etc. Again, you don't have to do this. If you just want to keep just a single idle character that, you know, is always facing down, that's fine. I'm not asking you to animate. I'm not asking you to do anything crazy with your sprites. If you want to, more power to you. If that is something that you are passionate about and you want to make sure that it looks great, cool. We have player X and player Y. So where is the player at? Player finish. So this is where does it need to go to. The speed. So the reason why the speed is 64 is because each of these tiles are 64. They're 64 by 64. So I have him move tile to tile to tile. And the reason I do this is so that I can cheat at the collision. It means that I can literally say, hey, we go down 64, and I know because I have this thing up here, I can check. If I go down 64, I'm going to be here. So I can check if I press the down arrow, whether this one is going to be open or this one's going to be closed. And that's basically what this is doing. Now, I'm not saying that mazes are the easiest thing to build, because collision is painful in any program. Collision can be very painful. So, that's a thing. And again, you can see, I have a lot of things that check collision. Then we have update. So, if the keyboard is down, move, do the things. All of these are separate. And then we have if our player where the player is at is equal to the finish square, then game over is true. And I know this might seem crazy and like a lot, and it's why I don't always suggest. Last semester, I had a few people make mazes and they were super successful. But I also had a few people try and make mazes and they crashed and burned and life was awful. So, another option would be to make a clicker game, which is what this is. And what this does is you're collecting fish. We can actually play. So you're clicking the fish up here at the top. It tells you. Is it much of a game? No, not really. But is it a game? Yes. I'm not asking for a lot. I really am not. Like, and don't think it's a trick question or whatever to be like, well, what does she want? And it be minimal. Because I know that this is not a priority for most of you. This is not something that you guys want to do. If you click the bonefish, they take like 5 points off or something. Yeah. So you can make a clicker game. 100% you can make a clicker game. And then another option would be to do like a dice game or a card game. Okay, yeah, so we'll talk about that. That's actually, you load them inside of Lua, or inside of, like, REPL, inside of Love. So, this is another, like, super simplified version. This is not a game. This is, I mean, this could be part of a game, but it's not a game. So, press space to roll the dice. It rolls the dice, and it tells you which side won. I want more effort than this, but cookie clickers are fine. Basically, if you're using REPL, you just come in here and you say add the file or add a folder, and you add the file and you put all of them inside a REPL. You can also just drag and drop them. So the same here, all of these are fish tiles. And the same for the one I already closed, which was nice game. REPL makes it super easy. As long as they're located with the stuff, it's happy. And then you can just call it directly rather than having to worry about where it's at. So ground 06 PNG. So that being said, again, my suggestion 100% is to look up old school arcade games, because generally if an arcade game is going to be relatively simple to kind of recreate. You could do Pong. Pong actually requires a lot of math. You could do Space Invaders, or you could do any number of things. Like, the sky really is the limit, but it's also whatever you feel like doing. I'm gonna warn you. I mean, you can even, and 100%, if you have me for level design, you already know this. I am fully expecting you to be like, hey Google, what's a tutorial to build a game in Love? And you may come in here and see what tutorials they have. You may watch this one, your first Love game in 200 lines. You may look at the GitHub that I gave y'all. Just images. It does not support GIFs. You kind of have to make your own GIF. So it'll support PNGs and JPEGs, but PNGs work better. But no GIFs. Yeah. And this one has, again, this has asteroids. It has a Flappy Bird clone. It has blocks. It has 15. It has some number games. I don't want them, if you're going to follow one of these, I don't want them to be just like this. Maybe if you have Snake, you might add some more power-ups. So maybe there's a poison apple, and if it eats the apple, it dies. Or maybe you've got like a golden apple, which speeds him up or takes certain pieces off of the end. I do want it to have a little bit of thought and it not just be a tutorial. There is one for a platformer that everybody really, really likes. So I have seen it many, many times. And I'm tired of it, but yeah, if you want to do it, I guess you're gonna do it. But you can 100% follow a tutorial if a tutorial floats your boat. They've got tutorials linked here. Again, if you work better with videos, there are videos for things. There are different things like that. Tutorial divided into main, index, basic concepts, things like this. And so it's up to you. what you want to do, how you want to do it. But again, the one that everybody tends to like is the platformer one. I think it's this one. It must be this one. These are probably all the same thing. It's probably this one. I just want to see whether it's probably this one. But so there's a few yeah, there's a few of them out there. Love tile maps. There's more than just a few. Like basically, if you can think of a tutorial you want to, or a tutorial that, or a, if you can think of a game that you want to make, there's probably a tutorial out there that teaches you how to do it. So again, if you wanted to just, this is another one that's pretty popular. If you just want it to be blocks, I'm fine with you just doing blocks. It doesn't have to be images. But I know at least some of you are probably more art oriented. So, if you want to make it pretty, go right ahead. I'm really honestly 100%, I'm not expecting this to be like the most amazing production quality ever invented. It's more that I want to see that you guys kind of understand how to make things happen. One of the questions I get a lot is, how do you make a pickup? And the answer is there's a few different ways. One, if you're just wanting to pick it up and add it to like a score, you just, when you touch it or when you do whatever, overlap, which is kind of how, if you either remember how we did or how I did the panda bear. So when the image is over 800, so you would check to see if maybe your player character or your mouse or however you want to do it, if your player character is within the bounds of where this pickup is, and they did whatever to it, if you had them press a button or if it was just for them being over it, add to the score or subtract from the score. And then you can either, you have two options. You can move the object to like -5,000 positive, or -5,000, -5,000, so you just move it off the screen and save it to be put back in. Or in your draw function, you tell it to no longer draw it. So you have an if statement: if player hasn't picked it up, draw it. If player has picked it up, don't draw it. Like, it's kind of that simple. Moving it over, to be entirely honest, tends to be more I don't want to say idiot proof, but I forget to code things a lot, or not. I forget to code, like taking that collision off, so I end up with like massive scores, and I'm like, why if I stand in this one spot do I get more? It's like, oh, I moved the item but not the collision. So, alright, like told the image not to draw but not the collision to happen, so moving the object tends to be the best option, in my personal opinion. So, yeah. Okay. So, questions. Utter terror. Confusion as to why I'm just throwing you in to make a game. Yep. Yep. Um, yeah. Yeah. Well, okay, so those of you who have me for both level design and for this class, I do kind of try and stack them so that they're due at different times. But spoiler, in this game you'll be making 3, 4 games, maybe 5. In level design you're only making 2. But this class is meant to be a lot simpler, and I'm expecting a lot from your level design games. From this class, not as much. This game should be easier. Yeah, if we come in, I can show you calendar. That being said, when it comes to making games, and this class specifically, so right now I've got you guys having 2 weeks of labs, and then it's due the next week. If we come in like next week and y'all are still struggling, or not next week, the week after, and y'all are still struggling and y'all are like, there's no way I'm getting it done in another week, we can push it back a week. Like we can pull it out a little bit further. I built in some padded time for an extra lesson. If we get to it, we get to it. If we don't, we don't. But yeah, so your love project, so your playtesting is due for level design, it's due here. But your full game for love is due here, and then your full game for level design isn't due until the next week. So I try to stack them so that it's not super crazy, but you can talk to the people who are taking, I don't actually know if it's being offered this semester. But if design and creation of games is being offered this semester, I don't know. I don't remember. They've got games to make. If I know game dev in C++ isn't, but you can talk to the people who took it last semester while taking both my other classes. So they had, one crazy Major Scott game due, plus my games, plus the other class's games. And then you had the person who was taking like 4 of them, so had literally a game due like every week. Yeah. I'm sorry. It's just how it works out. It's how the cookie crumbles. 100%, if you want to take the same game that you're making for level design and simplify it and it works here, be my guest. I'm not picky. If you guys made something in Scratch that you're like, hey, I think this could like transfer over here pretty easily, do it to it. Yeah, work smarter, not harder. I get it. But that being said, these can look good in a portfolio only because you can say, yes, I have experience in this other like strange language. Yeah. Yep. So, for those again who are like, hey, I'm saying like 3, 4, 5 games, what do you mean? You'll be making a game for Lua and Love. You'll be making a game for Pygame. You'll be making a text adventure in Python. And then your final is to take one of the games that you've made, so either your Lua game or your Python game, your Pygame game, and to kind of add in more functionality and zhuzh it up so that it looks better and it runs better, or make something completely new. And again, like I said, I've got a 2-week period, I think it's about 2 weeks, where if we have the time, we're going to look at JavaScript with Phaser.js to make HTML5 games. But if we don't, that's literally there to be thrown away so that we can push back Pygame so that you guys get another week, or push back Lua so you get another week. Yeah. That being said as well, you will have the next 2 weeks 100% lab time to make this game. So that will be 9 to 12:30 if you guys are awake on Saturday for the next 2 weeks to make your game. Of course you're mowing. Yeah. Yeah. I mean, you guys are lucky I'm not making you read 50 pages a night. Like, I'm giving you small discussions. And I'm not making you guys do tutorials like I do with level design. So, it could be worse. It could be worse. And since this game, the way that this course was meant to be, it was meant to be kind of project management and kind of scripting. I have to give you some sort of project management stuff, and the easiest, fastest way to do that is to give it to you through discussions. So, yeah. Okay, so with that said, do you guys want to walk through the googly eye thing? Or one of these other options? Which one do you want to use? Do you want to do googly eyes or do you want to do something else? Okay, we can do eyes. So, if you want to follow along, I gave you guys the link, and it's going to be this one. You're going to do new REPL. You'll go to Love 2D. You can call it whatever you want. Create the REPL. REPL created. Okay, let me reorient this so that I can see what everybody's talking about. Cool. So this is gonna walk you through everything, and it'll walk us step by step. So the first thing it says, and like this is logical, it's like, okay, so we want eyeballs, and we want the pupils to end up following. So what's the first thing that we need to do? We need to actually make the eyeballs. So the first thing that we're going to do is we're going to come in here and we're going to make our draw function. Remember, I told you that generally you have those 6 kind of lines of code, but that sometimes you can have one without the other. So function love.draw, and if we had any parameters they would go there, but we don't because it's love.draw. And we say, hey, love.graphics. Well, let's do this the other way. So the first thing we say is we want eyeballs, right? So love.graphics.circle is fill. Remember, you can have single quotation marks or double quotation marks. And we want to put it at 200 by 200. And we want the radius to be 50. Because we do. Just because we do. And we're making one eye at a time. Because technically, why would we make 2 eyes when we can just make one and then duplicate that one eye over? Like, again, work harder, not smarter. So we know that this is the eyeball, but we also know we want to make it white. So we've got to say, hey, let's set it to white. So love.graphics.setColor. And remember, I talked about this, where this is set on a 0 to 1 scale. So, a 0 to 1 scale. So this basically, you're going to have to translate, you can divide the number by 256, and it'll give you what the color code is inside of 0 to 1 scale. But if you want full white, it's going to be 1, 1, 1. If you want full red, it's going to be 1, 0, 0. You want full green, it's going to be 0, 1, 0. You know, so on and so forth. You want purple, it's going to be 1, 0, 1. Those kinds of things. So, and you can find, generally, if you can find an HSV number set, you can kind of find what you're looking for. But, yeah, you can just divide by 255 or 256 and you'll get close to it. So, this creates our eye white. Now we need to create our pupil because Otherwise, it's just a creepy circle. If we run it, we can see whether it'll run without all this other stuff. And it should. It's thinking. Okay, there we go. So see, we've got an eyeball. We have this white globe floating in blackness. Yeah. So the next thing we want to do is we want to create the pupil. So since we know it's going to be a pupil, and we kind of already know, we want to set the color. So we're going to say love.graphics.set color. And we know it's going to be 0. Well, we don't know, but it's going to be 0, 0, and 0.4 to give us kind of that navy blue color. And right now, we're going to say, well, we don't really know how we want to move this or how we want to get this, so let's go ahead and give it a value just to have something graphically there. So we can say love.graphics.circle, and we want it to be filled, we don't want it to be a line. And then we want it to be at 200, 200, so we want that to be the center point, but we only want its radius to be 15. So if we run it, we have an eyeball. So occasionally this is going to be a thing. Occasionally your cursor will turn into an X instead of an arrow. Just deal with it. It's REPL being REPL. I love REPL because it's really easy and it makes it easy to access, but it does have some inconsistencies and some small little issues that maybe aren't so small. So, we have an eyeball. Yay. Life is good. But we actually need to make it so that we're talking about, you know, where is the eye? Where is this center? Where is this pupil going to look at? And the next step is to kind of figure out how we get, you know, the distance from the mouse, to the eyeball, because we need to know where we're at so that we know how to rotate and how to turn. So with that, we can come in here at the very top, and we're going to add some local variables. Remember, local variables, all it means is that they're not global, so they can't be accessed outside of this function, and they're kind of deleted when they're no longer needed. And to do that, we just say, hey, local, and we say ix equals 200, because we know that our eye's center is at 200, 200. And local iy also equals 200. So the next thing we do is we want to say, hey, we want to get the distance between the mouse, so the difference between the cursor and that center of that eyeball right now. So we're going to say local distance x, and we're going to get the position of the mouse by saying love.mouse.getX, which is a function. And all this says is, hey, take the love engine, look at the functions that it has for the mouse. Oh, the function that I want to use, I want to get the X position. So we're going to say, you know, get the X position, which is over here. And then we want to subtract where IX is. So we want to get how much distance is between them. And some of you may be going, wait a minute, that's going to give us some negative numbers. And it does, and that's fine. Because that'll tell us whether we're on the left or the right of that pupil. So, we do the same thing with Y. And we're pretty good to go there. Now, we want to say, we want to be able to make sure, we want to test and make sure that this is actually writing what it's supposed to. We could just print it down here, But to make it easier to see, so that if we have this like completely down here so that we can't see the console, we're going to go ahead and add a section down here that's print the values of things, because we're going to end up printing more values. So the first thing we're going to do is we're going to set the color back to white, because remember we've set it to this navy color. Now we got to set it back to white. So love.graphics.set color, or we could change it to another color if you wanted to. So let's see, let's set it to purple 101, and then we're going to use love.graphics.print, which you guys have seen. That's how we just print a line of text. What's going to be different is you're going to see this thing that says table.concat. And we've talked about concatenation. Concatenation is where you kind of, you take two strings and you mush them together. So that's basically what this is doing. This is saying, hey, take all of these things and put them up there. Just put them together for me. So what we're going to do is, concat is a function, and it's a function from C rather than a function from Lua. And we're going to make a table. Remember, tables are just the special versions of an array. And we're going to do distance x. And we're going to use those two dots. Remember, that's how we kind of add something to the same line. And we're going to say distance x. And then again, remember, it doesn't matter. We could press the return key if that helps you, if that's easier for you to see. So a lot of people like to do it that way and then this way, so that you can for sure see the difference between them, or the different elements inside of your table. And to end everything out, we're going to do an N. So, not an N. So now, when we stop this and run it, yes? Come on. I believe in you. There we go. You're going to see it's like, hey, wait. I don't like what this thing is. So line 17 says, syntax error. It was expected to be near this thing. And you're going to be like, so what is it doing? And what I've got to do is figure out, where the problem is. Sometimes these make sense, sometimes these don't make sense. So an in parentheses is expected to close near this end thing right here. And that's because I have one here that I wasn't supposed to have. So if we run it again, that should be the thing that fixes it. It may get mad at this comma right here. We're gonna see. There we go, it doesn't. So now we can see, if we move, we can say, hey, how close are we to the center of this eyeball? Where are we compared to this eyeball? Which is kind of handy in and of itself. You could play like a hide and seek game where, are you hot or cold, and have it a hidden item, and so until your mouse goes over it, it's black, and then as soon as your mouse hits it, oh, you found me, and it pops out. So that would be a way to do something like a hide and seek game. So without us writing too much code, we've actually created something that could be used for other things. And that's one of the reasons why I like this tutorial, because it's a lot of moving parts. It's a lot of different little things, but it might give you some ideas. So yeah, you know, we've got that kind of thing. So, next thing that we're going to do, and you can play hot and cold. That's the other thing, like with it. You can be, are you hot, are you cold, are you close, are you not? You can also like tell it when it clicks rather than to only register when it clicks, which would be another way to do like a hide and seek kind of game. So the next thing we're going to do is we're going to get the straight line distance, which is slightly different. And again, I told you guys this one's a lot of math. I like this one. It is a lot of math though. Those of you who haven't taken math in a while, you probably still remember at least the words Pythagoras and Pythagorean theorem, which is basically a squared plus b squared equals. So, yeah, that's a thing. So we're gonna look at that, and we're gonna look at that using square roots. So basically, what it boils down is to the square root of the distance on the x-axis squared plus the distance on the y-axis squared is the distance in a straight line. A squared plus b squared equals c squared. Yeah. So, to do this, we're going to come down and we're going to add another local variable. And we're going to call it, hey, local distance equals math.square root. This is a built-in math function coming from C. Distance x, if I can type today. And then I talked about this where sometimes inside of Lua there's multiple different ways to do exponents, and some of them are supported and some of them aren't. For this one we can do that. It's simple enough that it's going to understand that. But a lot of times you're going to want to go and do math.pow. So, and to do that it would be math.pow. And it would be your number, so distance x and then 2. But for the sake of this one, we can just do, and so that we don't have so many parentheses smacking this thing, we're just going to do distance x caret 2. If you didn't know, that's what that's called. It's called a caret. And then we're going to add distance y caret 2. And then we're going to add down in this table, we're going to add another line, just so that we can see what the difference is between these. And it's just going to say distance. Because basically now, instead of getting the x and the y, we're getting, you know, just the line. Just the one straight line that we need to find out. So when we run it, you're going to see that there's an issue. Line 8. Oh, because I put a comma in here. And that's when you get a syntax error, look at what line it's pointing to. It's actually pretty smart. It tends to be pretty smart. So, it's going to tell us what the distance is between them. So what these two kind of create with the Pythagorean theorem. Because if you don't remember the Pythagorean theorem, it's talking about how to create a triangle. So you take the 2 points and then what's the other part of the triangle. So it's telling us, so that's how we're getting our positive number. That's how we're getting our 100% positive number. So you can tell if we're here, we're about 183. In the same way, if we're here, we're about 183 as well. So, now we've got not only our x distance and our y distance, but also the actual distance. Again, this could be helpful if you wanted to do a hot and cold game, a hide-and-seek game, something that has to do with your mouse trying to get something. This would be a great way to incorporate that. So now we need to know about the angle. And that's basically talking about, angles. It's talking about angles. We'll just go with that. So remember, in love, love takes things the hard way and decides that things are now going to be in radians rather than in degrees. So we don't quite have to remember that yet, but it is going to look funky when we do it and you get your tangents. So up here in our locals, we're going to write another one. Local angle. And again, you could technically at this point make all of these not local and there not be a problem. Really, you could without any kind of problem. And we're going to take from our math library again, and we're going to do a tan 2, which is a form of tangent. And we're going to do distance y, comma, distance x. I'm not going to go into tangent. Tangent has to do with kind of like the angle that something meets things at. Just, if you remember, you've got tangent, cosine, and sine. And they all have to do with waves and curves and lines and all sorts of things that you don't really have to remember unless you're in a math class. You'll use them seldomly inside of, unless you're like a heavy programmer, you'll use them really seldomly. Occasionally you use them in programming, actually more than occasionally you use them in programming for different things. In game programming, not as much, until you're trying to do something on a little bit of an older system or a simpler game engine like this rather than something like Unity. Don't get me wrong, you'll see them inside of Unity too, but not really. Okay, so once we have this, we're going to come down here and we're going to add to our print table. And again, the only reason why I'm spacing this out is so that I can see them kind of in two lines. You don't have to. And if we run it again, you're going to see that we now have angles. They don't mean anything to you. Remember, angles have to do with, and the way that radians are done is why we're not seeing, 45 or 90, those numbers that we're used to seeing. It's because we're working off of pi, whereas a full circle is 2 pi, 180 is pi, and so on and so forth. So now that we have that, we want to move the pupil. That's kind of the whole point of this thing, right? Is to move that pupil around. So if you look at this, it's got a long explanation here. The cosine sine of the xy position gives the ratio between the xy position and the straight line distance. That makes no sense to anybody, does it? Thankfully, it explains it. When the mouse is directly below the eye, all straight line distances goes into the y-axis, so cosine is 0 and sine is 1. When the sine is 0.5, the y distance is 0.5 of the straight line distance. So it's just talking about, which one has more emphasis, the y or the x. That's what we're looking at with cosine and sine. We're looking at whether it's the x position or the y position that has more influence. So, come down here. Again, we're going to add even more of these. And you can comment it out if you want, or you can comment things if you want. Like I started commenting with the eye white, the pupil, etc., etc. I don't always comment out my local variables or my variables in general. I try when I'm giving you guys stuff. So if you noticed in the rocket things, all of those are heavily commented, so they should help you with that kind of stuff. So I do space things out a lot. Some people like that, some people do not. I like it because it's easier for me to find things. So, and then I group things together. So local pupil x equals ix plus, and this is where more math comes in, we're going to do math.cosine of angle times the distance. And then local pupil y is going to be sine. So just remember, sine is going to be your y and cosine is going to be your x. Equals iy plus math.sine, or sin, angle times the distance. And then, of course, we're going to come down here and we're going to print it. We're going to say, hey, cosine of angle. So that's our x value. Remember, that's our x value. And if you want, you can put x in parentheses if that helps you. And then you're going to do math.cosine angle. Now, why are we printing this instead of printing, you know, pupil x and pupil y? That's because right now, this we're still working on. This is interesting information. This not quite yet. Again, you can 100% have this just print to your console, but one of the plus sides of printing it to your screen is that you're not having to like worry about it firing every frame and you seeing it reprinting things even when you're not moving. So yeah, that's one of the plus sides of that, if you were curious. So, when we run it, okay, there we go. The numbers, again, they don't mean anything to you yet. They will probably never mean anything to you. Those of you who are math junkies, they do mean things to you. Again, I'm not sure how many of you like math. I'm not sure how many of you don't like math. But what you're going to notice is you're going to notice some things when we're on the left side of the eyeball. We're getting a negative number in the x. When we're above the eyeball, we're getting a negative number in the y. When we're to the right of the eyeball, we're getting a positive x. And when we're below the eyeball, we're getting a positive y. Remember, part of the reason why we're doing that is because 0, 0 is this top corner. So this is further away and is a bigger number than up here. Also, I'm sorry if you guys can hear everything in the background that's happening. We had a water pipe break, so they're here fixing it, and part of that is keeping the dog happy so that he loves the people who come to work on the house, but part of him loving the people who come to work on the house is him yelling really loud. So they're trying to keep him cool and calm. So I don't know if you guys can hear anything. Sometimes my mic picks it up, sometimes it doesn't. So yeah. If you can, I'm sorry. Yeah. Okay, so we've got this kind of setup, and as I'm using my mouse on the screen that you guys can't see. So we have all this kind of set up, and we can kind of see how this is working. We can kind of see when we're all the way down at the bottom, we're at 0.99, so we're close to 1. Maybe that says something. And if we're close over here, we're at negative 0.99. And if we come over here, we're at positive 0.99. And up here, we're at, so that should kind of help thinking about this, but, If it doesn't make sense, that's okay. Don't worry too much about it. Know that it works, and that you can just literally pop this code in for other things for it to work. So, now we actually want to get the people to move, right? That's kind of the first thing that has to happen. Or not really the first thing that has to happen, but it's something that we want to kind of do. Did I skip a step yet? No, I should be fine. X distance, pupil X, pupil Y. Yeah, I think we're okay. I may have left something off. We'll see in a minute. Okay, I did leave something off. Okay, cool. So we've actually got to tell it that we're going to use pupil X and we're going to use pupil Y. So if we come down here to where we have our pupil, instead of this 200, 200, the first thing that we need to do is we need to say, hey, let's follow the mouse. Let's go to where the mouse is like telling us to go. So we're going to say pupil X and pupil Y. Now, before we get started, we know that this is going to actually like do some funky stuff because we haven't told it to stay inside of the eyeball. But for now, that's okay, because what we want to do is we want to make sure that it actually moves towards where the mouse is. So if we run it, thank you, you're going to see it's going to the mouse point. So, I mean, that's pretty cool, right? That's kind of what we want, except we want it to stay inside this eyeball. So now we have to say, hey, what's the maximum distance that this pupil can move so that it stays inside this eyeball, but still follows where the mouse is pointed to? So what we need to do is we need to add, again, another variable. And the reason why these are local, because I said you maybe could make them not local. The reason why these are local is because we're going to duplicate so that we're going to make 2 eyeballs. So we want to keep these variables local to each eyeball. So that's why. I couldn't remember why they did it. So we're going to tell it, hey, there's only a certain distance you can go. And that distance, we're going to look at kind of the distance. So we're going to look at math.min, which looks at kind of how you, it kind of looks at the difference between, like, what the minimum difference is, or the minimum number between X and Y. But what we're going to do is we're going to do math.square root. Yeah, that's fine. It'll get deleted. Or I can just, like, change it up here. But just to rewrite, so because we can literally just overwrite this without a problem. Because it's Lua, and it doesn't care. It literally doesn't care. like I said, we could literally say local distance equals Bob. Or Bob. And it'd be like, okie dokie smoky, that's good. Yeah, it doesn't care. We can, since we do already have it written, just come up here and say math.min and then comma 30. And that just has to do with the way that math.min, if you really want to know what math.min, if we type in math.min c, standard library, C library. Are you not going to be the one that tells me? No. Okay, so basically, you can find out what math.min does, but it doesn't always, it's not always helpful to find, like, it's, yeah. Know that it works. For this, if you want to know why it works, 100% go ahead and look why it works, but just note that basically what we're doing is we're saying, hey, constrict this to this amount, so take this and constrict it. So now when we run, yeah, one of the nice things, again, one of the super nice things about Lua is that you can overwrite variables. I mean, it's also an awful thing, but you can overwrite variables and it's never going to blink an eye at that. Like, oh, I named this thing distance up here. Oh, now I'm naming this thing distance. It doesn't even have to be the same type, and it's happy. So yeah, so now we have an eyeball that's following a mouse. Notice it gets a little freaky when it like tries to come and like figure out what you're doing right around the center, but we're okay with that because right now we have an eyeball that's following a mouse. It's kind of cool. So now we have a Cyclops in the dark, but the problem is that we kind of want now to do two different eyes, right? Now, if we look here, this is basically the code that we've all done. What they're going to do instead, though, is that they're going to confine it to a function, so that then we can switch it over to where the IX and the IY is. So, to do all of this, we no longer need these two variables, and we can just write, and you can write functions inside of other functions. That's another one that gets people, like, every time when you're coming from things like C++ and Java. Lua is 100% like, you want to write a function inside of a function? Cool. You want to write a function inside of a variable declaration? Even cooler. Like, Lua breaks every rule that you can think of. Which is honestly one of the reasons why I find it so lovely. It's the kind of programming that you would think you would do when you were really, really drunk. Y'all are all adults or adult adjacent. Yeah, it's the kind of programming that you honestly, you think of somebody's either super, super brilliant when they're drunk programming, or you think of that person that's like, what happens if we put, if we create a data type for nothingness, and we end up with nil. So, and basically we're going to create a function called drawI, and it's going to take two parameters. It's going to take IX and IY. We know that those are supposed to be numbers. But technically, you could put something in that wasn't a number. This is where, again, you would probably want to validate to make sure that the numbers that you're putting in are actual numbers. But so once all of this is in there, then we're going to come down here and we're going to say, hey, end the function. We're not going to say end the function there. Totally not going to say end the function there. We're going to make sure that we add this stuff. And remember, it doesn't matter whether you whether you actually tab over. Sorry, I was trying to think of what I was trying to say. Whether you tab over or not, tab is just a lot easier. And because we know all of this works, we can get rid of it because we don't really need it anymore. It was just for testing purposes. Now that we know it works, we don't have to worry about it. And we just want to make sure that we end our function because everything has to say end because we've got to know when the thing is going to end. And then we can say, hey, we've got all this function, so let's call the function. So draw I. And so the first I, the center is going to be at 200, 200. The second I is going to be, and this is 100% because that's what they felt like putting it at, is going to be at 330, 200. So now when we run it, if I haven't messed it up completely, yes, please run. You're going to see that I have messed it up completely because I've probably deleted or gotten rid of something that I wasn't supposed to, which is a general thing for me. What did I do wrong? Let's see. 200, 200, 330, 330. That would be a thing. Right there. Thank you. And again, oh, that's not even it. This is a thing that happens more often than not, where you just have to sit there, and it's always something simple. Like, generally, when you mess up code, it is something ridiculous simple that you're like, how did I not see that initially? And the answer is because I didn't. And it's, yeah. When it comes to things like C++ and Java, or C#, it's that you're missing a semicolon at the end of a line, or you've misspelled a variable name. When it comes to this guy, it's doing something like that. Which should maybe now work. Okay, yeah, so now we have our eyeballs working, and see, it follows our mouse. Woo! So kind of interesting. Maybe a little for y'all. Again, I don't 100% suggest like having a cannon that fires in the direction of your mouse button. That can get, I had somebody try to do that last semester. That can get problematic. It's not hard, asterisk mark. It can be hard, depending on how you're trying to do it. They tried to make a pirate game where, depending on how your cannon was pointed, it shot in that direction, and then it shot towards the player, and it overcomplicated things. Again, I'm not meaning for these to be super complicated. It's basically just to say that you have the experience of making the game in this. Okay, so, question time. Do y'all have any questions? Have I completely lost you? I'm going to take silence as dazed and confused, sleeping, or that you're okay. So the other question is, were there any others of these that you wanted to walk through? We technically have about an hour left in class. Generally, this is the point where I want to let you guys go so that you can have time to do a lab, so that you can do those two things that I have for you guys, your drawing assignments. Your drawing and your motion assignment. Yeah, 100%. So I will say that what I thought about doing for next week, again, remember, I won't be here next Saturday because I've got family stuff, and so I'll be out of town for the weekend. But I will have a recorded video up for you. So what I was going to do as well was I was going to pick another one of these to walk through and talk about. Um, Probably asteroids, because the person who did, I had somebody who had to make up a bunch of assignments, and so what I did was he had to do all of these. Flappy Bird gave him a lot of trouble, so that one I don't suggest trying. But we can look at one of the other ones if you guys want. But my plan for next week was to leave a recording, like walking through one or two more of these. But I will 100% go through. And remember, next week, technically, Canvas, etc., will not be accessible because, or next Saturday, because they're doing maintenance for the entire day from 3 a.m. to 5 p.m. But yeah, which one of these would you guys like to look at if you want to look at another one today? We have Snake, Repeat. I don't remember what Repeat is. 15 is a slider puzzle. I had somebody do kind of a riff on this one with images. Like they had an image that they cut up using sprites, and it's really cool. Blocks is Tetris. And then Asteroids, if you don't know what Asteroids is, it's just, yeah. It goes boom. Asteroids. Okay, yeah, we can do asteroids. Let's look and see how long it is first. Rules overview. Okay, yeah, we should be able to do this. We might go a little over on time, but we should be able to do this. I will say this one gets a little bit complicated. But yeah, we can do this one. So, the way that this one works, destroy the asteroids with bullets while avoiding asteroids touching the ship. Bigger asteroids break into two smaller, and faster asteroids when hit with a bullet, and the smallest asteroids are destroyed completely. Okay, you've probably, if you haven't played Asteroids, you've played something similar. Because it was like ridiculously revolutionary when it came out. Like everybody's like, oh my god, this is the most amazing thing. And so it's been ripped on so many times. So controls. It uses S to shoot the bullet, the up arrow to accelerate, and the left and right arrows to turn. So the ship has an X and Y position, an X and Y speed, and an angle that it's facing. And then, asteroids and bullets is represented by a table that has their XY positions, as well as the angle that they're moving at. The bullet additionally has a number representing how long until the bullet is removed if it doesn't hit an asteroid. This is super important in game development in general, because if you don't, tell it to go away, or to stop moving, it's going to keep going forever. So it's going to keep adding to your memory. It's going to keep adding because your computer's going to still keep going, and the computations are going to get more and more and more complex as it gets, into the millions and billions. Each asteroid additionally has a number representing its stage, so if it's big, medium, small kind of thing. There's a table which contains all the asteroids and another table which contains all the bullets. So each bullet is checked to see if it collides with any of the other asteroids. If it does, both the bullet and the asteroids are removed from the table. See if it collides with the ship, so the game is reset. If there are no asteroids left, the game is also reset. So whether you win or lose, it just resets it. So that objects partially off the edges of the screen can be seen on the other edge. Everything is drawn 9 times above the screen, below the screen, to the right, diagonal, and left position. So basically you create kind of a repeating pattern so that you can make sure that it's always seen. And our good friend Pythagoras is back again to kind of show you how things work. And again, this works kind of the same way that the googly eyes did. So, again, there's lots of things talking about this. If you want to read through all the math, it's really cool if you like math, if you're kind of that person. Like, I really enjoy math, but I know that I'm definitely in the minority there. So, okay, so let's go ahead and do a new REPL. Love 2D. Asteroids tutorial fall 2020. Create REPL. So again, just like with the last one, the first thing that we want to do, it's telling us, the first thing that we need to do is to draw the ship. And I realized as I was talking, I totally didn't have that tutorial on the screen, so it literally probably made no sense when I was motioning and talking, but I'm sorry. So the first thing we're going to do is we're going to draw the ship. So we need a function love.draw. And this is just a personal preference. I always write these 2 lines together before I write anything else, so that I make sure and know that I've added the end statement in. Because that will drive you bonkers when you forget to put an end statement in. Because you will look everywhere and try and figure out what it's trying to tell you is wrong. And the reality is it's an end statement. So if you write them together to begin with, even if you're writing an if statement or a while, like whatever you're writing that requires an end statement, as soon as you write the condition or the function name, you write the end. And then you can put stuff in the center. So let's make the ship. Love.graphics.set and we're going to make it 0, 0, 1. So remember, this is RGB, so the ship is going to be a blue. And then we're going to say our ship is a circle. Love.graphics.circle. We're going to fill it. Remember, that can be single or double quotes. And then we're going to say, in the thing they have 80 divided by 2, 600 divided by 2, and 30. What we can do instead, and we talked about this, is that we can do where we get the screen width and the screen height, and then we can divide it by 2. Love.graphics.get width divided by 2. Love.graphics.get height divided by 2, and then our radius is 30. This tends to be a better option as long as I wrote it right. And the reason why it is because this means that if we go in and we programmatically change how big our window is, by default Love makes it 800 by 600, that this too will also change so that it's in the center. So instead of doing it just 800 divided by 2 and 600 divided by 2, I set it up this way because then I know for sure that it's in the center of the actual page.
So now we can see our ship. It's pretty. It's blue. It's a circle. It's so amazing. The graphics are so real. So we need to get the ship moving. And it says when the right arrow is held down, the ship's angle increases at a rate of 10 radians per second. To show the angle of the ship, a light blue circle is drawn 20 pixels from the center of the ship in the direction of its angle. This uses the ship's X and Y positions, so they are made into variables. So, we're talking about how we need variables that are kind of accessible by everybody, and they need to be kind of set up first, so we know that they're going to be in love.load. So we're going to say, hey, the ship X to begin with is equal, and remember we've got these values, so I'm just going to take this out. And we're going to replace this with ship X. And then ship Y is going to be this guy. And then we can see that that's actually going to work now if we run it again. We're all happy. Nothing's changed. We just changed it out for variable names. And then we need one more variable up here because we need that whole angle thing. So ship angle equals 0. And this is setting it to 0. Because if we kept it at a nil, it would probably error out because we can't actually follow it. So, now we need to get this whole angle thing going. So we're going to do function, and we know that we're going to have this whole angle because we're going to do the whole updating thing, so we can know that we're doing update, and that we're going to do delta time because we want to make sure that we're doing things in time rather than by frame. And we're going to say if love.keyboard, so if the keyboard and if the function is down is called, and what button do we need? We need right. So the arrow keys are just up, down, left, right. That's their names. So all this is saying is if the right arrow is held down, then, and remember, even here, I put the end before I start putting anything inside, because otherwise there's a good chance that I forget. Ship angle equals ship angle plus 10. Remember, because we said as long as that is held down, every second it moves 10 radians. Times dt, so that we know that it's moving like it's supposed to. And then end and end. Now we actually have to draw the thing that's going to use this. So we have our ship. And remember, we want this circle to be on top so it comes next. So this is the stuff that's furthest in the back. We want this circle to be drawn on the top. So we're going to do love.graphics.set color. And we're kind of doing this aqua color, so we're mixing green and blue in equal amounts. So we're doing 0, 1, 1. And it's okay to have it this way or this way as a side note. It depends on what you want to use and what you want to look at. Yeah, it just depends. And I won't care either way. I really don't care about that. So then we're going to do a local variable. And they're going to call it ship circle distance. and we're going to equal it to 20. So that's how far away this kind of like second circle thingy is going to be. And so then we're going to say, hey, let's make that circle now. So love.graphics.circle. We're going to make it filled. That helps. We're going to make it filled. And then we're going to do some funky math. We're going to say the x value is equal to shipx plus math.cosine of the ship angle. Remember, we talked about this. Cosine is x and sine is y. And then times it by, multiply it by ship circle distance. Remember, this is going to look nicer like that. Or we can do this way. And then, because this is literally the same thing, only a couple things changed, I'm going to copy it. I'm going to paste it. We know that this is sine because it's y. So we need to change this to y. And if you ever see me highlighting something this way, and you're like, how is she doing that? I don't see the mouse cursor. If you hold in any program, basically in Word or Unity or Visual Studios, if you hold the Shift key and any of your arrows, it will highlight letter by letter. If you go up and down, it'll highlight line by line. There's a whole bunch of things. If you hold that Shift key with the arrow keys, you can use Control and a bunch of other stuff, and it'll do more things. But yeah, so that's a thing. So the next thing we need to do, though, is we have this, and then we have one more value, because we need the radius of what this small circle is going to be. In this case, it's going to be 5. It's going to be tiny. So the tutorial itself has us doing... Oh, that's not helpful. Yes, that was right. No, that's not right. There we go. Now we're good. So the tutorial has us doing, so again, some kind of like print statements that are going to be temporary. So it actually tells us this time that it's temporary. So love.graphics.setColor. We're going to set it to white. So there is actually an option to have a fourth variable on this as a side note, and that creates your alpha channel, so how transparent the thing is. So you just add another number in. So now when we run it, we have this little circle. And it's technically, you know, nothing is happening. Like it's, why is nothing happening? Something should be happening. What did I do wrong? Oh, that would be right. Because I was using the mouse and I was meaning, and I needed to be using the arrow. So, if the right arrow key is held, we can move this little circle around So we're all good. I didn't do anything wrong. Yay! I just read the directions wrong. Boo! So that works. So we've got our ship angle. We have this little circle that indicates which way we're pointing. And life is fine. Now, we need to do it for the opposite. If the left key is held, then negative. So it's literally the same as this one right here. And again, because it is the same and there's just a few things changed, I'm going to copy it. And I'm going to paste it. And this one becomes left. And this becomes a negative. The same way that we do movement. You know, this idea of if you want to move in one direction, it's positive. If you want to move in the other direction, it's negative. It's the same thing. We're just rotating. So now, when we play it, sometimes you're going to see this down here. If it starts doing that, just click inside of your play window and then it should be happy. So if I click the right arrow, if I click the left arrow, you can see we're moving clockwise and counterclockwise. So we're good to go now. Like, we've got that working. Now, there is one thing. If you noticed here, if we keep going, we're getting numbers like 16, 20, 25. Remember that an entire circle is 2 pi. So we're talking 6.28, you know, they're around. It shouldn't be going like we're just going more and more circles. So the next thing it has us do is like, hey, you know, we don't want it to go that high. Let's just let it, you know, it's a circle. So once it gets to 2 pi, let's go back to 0. You know, let's circle back around. Makes sense. And for this, it's going to use modulo operator. That thing that you all hate. Remember, the modulo operator returns what's left over. So when you're talking long division and you divide 10 by 3, you have that pesky 1 that when we talk about decimals turns into 0.3333333. When we're using the modulo says I could care less that 3 goes into 10 3 times. I want to know about that one thing that's left alone that doesn't have anywhere to go. That's what I want. So we're going to use that to our advantage. And inside of here, where we've got these equations, we're going to say, hey, let's look at the modulo and make sure that it returns, you know, so that it's within 2 pi r. So, or not 2 pi r, 2 pi. I've probably said 2 pi r 8 times now. So all we're going to do is multiply or use the modulo operator, so this guy. And then we're going to do 2 multiply math, again, math is our friend, dot pi. So we're going to get pi rather than having to put 3.14 because 3.14 is technically not pi. 3.14 is a simplified version of pi, and we want actual pi. So let's use math, which already stores pi up to a ridiculous number, and we'll use their math. So again, just going to add that here as well. And yours does not, especially like the games that you're going to make, please don't think that it has to be this sophisticated, that it has to be thinking about these kinds of things. You're going to go over angles, fine. If it works, if you can get it to work that way, do it. Do something that makes sense to you. So, you're going to see, why are we not doing? Oh, that's why. Parentheses matter, guys. Parentheses really matter. Again, because of the way that was, it evaluated things differently than what it should have, so it didn't actually do what we needed it to do. So now it should. If life is nice, it should. So see, it's circling back. We can come up here to 6, and then we go back down. So that's what we should be getting. Parentheses matter. Okay, so the next thing we need to do is we need to start making this ship move. The ship is giving an X and Y speed. When the up arrow is pressed, the ship's X and Y speeds are changed based on the ship's angle. The ship's X and Y position are changed based on the ship's X and Y speed. So, we need speed. Makes sense. Inside of here, inside of our load, we're going to give it an initial value. So ship speed X is equal to 0, and ship speed Y is also equal to 0. Remember that if you're having a hard time not putting end lines, you can 100% do those. If that helps you, like if you're taking another class right now, another programming class, and it's killing you to have to remember that Lua technically doesn't have them, but Java, C#, C++ do. Lua is cool. Lua knows that that's a problem for a lot of people and will let you do that. So if that helps you, go ahead. Yeah. So, okay. So we've got that. In update, we now have to say, what are we going to do if the key is pressed? If the up key is pressed. So we're going to say, hey, if love.keyboard.isDown, and again, we're going to take up, then, remember I always write end, and then we're going to say, they're going to add a local variable, so we're going to say, hey, local ship speed equals 100. And that's saying, hey, outside of this, the ship speed is still going to be whatever that global variable is. But for now, we're going to take this thing. And so we're going to say, hey, ship speed X is equal to ship speed X plus math.cosine. Again, remember cosine means it is X. Ship angle times ship speed times our trusty friend dt. And again, y is basically going to be the same, so we're just going to copy what x is saying. We're going to paste it. Shift tab will tab that back as a side note, whereas tab will tab it forward. We'll tab it forward when it's not done stupid. Shift tab will take it backwards for you. So we know that this needs to be switched over to y, that because it is, and because this is y, it needs to be sine, and we're good to go. Now, outside of this if statement, we need to actually apply what ship x and ship y is going to be, as far as like where it's going to be. So ship x and ship y. So based off of this stuff that we're doing, where are we going to put it? And sometimes it's just going to be the same place that it was, but we would need to actually tell it to move. So ship x equals ship x plus ship speed x times dt. The same with ship Y equals ship Y plus ship speed Y times dt. Okay, so we have that. So in our temporary, we kind of don't need this anymore. We're do we really want this? Do we need this? Yeah, maybe we can. So let's go ahead and concatenate a table so that we just build a whole giant line of stuff. And let's concat it. And then we're going to say, yes, this is going to be the first thing that we want. So let's put a comma. Then we're going to say, hey, let's take ship X. Let's take ship Y. Let's take ship speed for X. And let's take the ship speed for Y. And then let's just add the new line operator just in case. And remember, this is another place where I often tend to put these together. So you need to remember that you've got like which ones these are going to match up to. And right now we only have one, and we technically need two, because we need the one to fill here and the one to do here. And when you start typing them, they will show you which ones they match up to. So it's pretty nice. Okay, so we have that. And if we run it, and again, I haven't done anything wrong, which, as y'all have seen, happens quite a bit. So we have our ship angle, and if we press the up key, you see we're just moving in that direction. And we keep moving. Now, what we need to do is we need to make the ship, when it goes off the edge of the screen, come back to the other side. So again, we're going to do pretty much the same thing we did with this other, when we were using the modulos. This thing. We're pretty much going to do the same thing only for our ship. So the first thing we have to do is we have to get our arena width and our arena height. So again, we can do arena width equals love dot and then arena height as a side note, name things you can spell. I know that seems like, of course, why would I not name something that I can't spell? But there are certain words that if you write them over and over again, they start not looking like they make any sense. So just be careful. with words. Like height is one of mine that after writing it 800 times, I'm like, this doesn't look right. So just note that that's a thing. So because we're storing these values, we can 100% switch this over to arena width. And arena height. Make our lives a little bit easier. And then in our update, we're going to come down here where we have this whole ship X and ship Y. And this one right here. We're going to go ahead and we're going to do our modulus. So we're going to do this. And we're going to say, hey, arena width. Arena height. And now, when we run, so we're pointed in that direction when we start moving. It's going to be checking to see, hey, are we off the arena? Are we, like, what are we doing? And you're going to notice that there may be some times where it seems to be moving faster than others. And that's just the nature of the beast about how angles work with speed. So if things worked, you see we're down at the bottom. And we're just going to keep moving around the screen. So now we have to draw partially off-screen objects. This is that idea that you have to draw it 9 times so it creates that tile thing. So that they kind of, yeah, so that you see them on both edges. So to do that, we're going to come into here. And remember, because we want to draw these asteroids behind the ship, we don't want them to be on top of the ship, we want them to be behind the ship. We've got to do these before we draw the ship. As a side note, if this isn't interesting to you guys or helpful, please don't think that you have to stick around. I 100% am, yeah, that's on you. So we're going to make a while loop, or we're going to make a while loop. We're going to make a for loop. So we're going to say for y equals -1. Our increment is going to, or our top number is going to be 1. Our increment is going to, no. For y equals -1, 1, do. So while it's doing things, do. And again, remember we've got an in loop or an end for this. So do that thing. So then we're looking at the y's. Now we're going to look at the x's. For x equals -1, 1. So step 1, do. And again, we need another end for this one. And we're going to do a new thing, love.graphics.origin. Origin is just looking at the origin. I mean, that makes sense, right? And then love.graphics.translate, if I can type, is going to actually translate things around. So x times arena width, comma, y times arena height, and now we're going to add into here. We're going to do a temporary love.graphics.origin. That should be, yeah. So it should show up when we're half and half. For y equals, oh. Even though Lua is something that I write in quite often, that's still one that I always, for whatever reason. We are running the REPL. Come on. There we go. Yes? No? Maybe so? Okay, so 35. Haha. Again. Spelling. Spelling is helpful. Again, this is one reason why it's nice to have like the Lua and Love, like an external compiler, because it will like underline and squiggle things. So now our ship has completely disappeared, which was not what was supposed to happen, I don't think. It's moving. It's somewhere. It just, you can't see it. Why can't you see it? So I did something. What did I do? What did I do? X times our ninth, y times our ninth, margin, x equals -1, 1. Okay, if anybody sees what I did wrong, let me know. 0, fellowship x 5, 0, 1. That's gonna be a problem. that would help. Again, where did it go? It's doing things. Huh. Okay, so stop. Let's see here. As far as I can tell, oh, okay. So it looks like something in the origin statement is like messed up. So for now, we're just not gonna worry about that. And that may be something that's been changed inside of Love. But we should be okay without it. Considering class is technically over, and we're about only about a third of the way through. Do you guys want me to keep going? Do you want me to go ahead and record the rest of it to go with this? And then a different one for next week? What do you want to do? Like, technically, this will walk you through everything. Like, it will walk you through everything. But yeah, I can 100% record walking through all of this. And because I know that some of you probably want to go eat or want to go do whatever the rest of your day has for Saturday. I know some of you work. So yeah, I can record the rest of it. It means that the video for today will be a little bit later than general. Just so that I can get through the rest of this. And see if I can figure out what the issue is with that origin statement. But the other one that I know people really like to look at is the snake game, because a lot of people like to make snake.
Hi there.
Yeah. So, with that said, if you want to stay in Discord, I will continue to do this. And you can come and go as you want, but I'll also finish it. It'll be part of the recording. So, again, work on your game, come up with an idea, start thinking about it. Next week I will not be here, so there will be a recording. But Canvas will also be down on Saturday, so it's kind of a catch-22. That being said, you've got REPL, so you can 100% do things on REPL. I will post up a kind of project check, and it will be worth points. And it's just going to be for you to say, hey, this is what I'm working on, or this is what I'm doing. And it's perfectly acceptable to say, well, I didn't get anything done this week. That's okay. I get it. Sometimes life gets in the way, and sometimes life is a new video game. I get it. I really do. Just know that there are due dates, and you guys have to worry about time management. Okay. So if you want to go ahead and leave, because it is 12:30, be my guest. Otherwise, I'm going to try and knock this out in the next 30-40 minutes. Hopefully less than that. Yeah. Okay, where are we at? Why are you not working? And Love Load Arena, Shipway, Function update, if. We'll just figure it out later. So it looks like this is a line causing problems. We'll see if it fixes itself later down the line. I know the problem is that it's translating from here over to here. Why aren't you ready? it's clamping it so it can't come all the way over. Okay. Okay, so that sort of makes sense why that's doing that. That's because here... That's the problem. So update... Should be... Okay, whatever. We will come back to that. Okay. So let's just go ahead and get on with the show. And we'll see, because it'll cause problems, but we'll work around it. Because I honestly don't know what I did. So let's look at bullets. Inside of load, we have all this stuff. So let's go ahead and start our bullets. So what we're going to do is we're going to do a table that holds our bullets. And that's how you make a table. That's it. So inside a draw, inside of our for statement here, we're going to add a new line for bullet index bullets in iPairs bullets do. Ooh, is this the old way to do that? Love.graphic. That's definitely not words. Love.graphics.set color. I'm gonna make these green. 0, 1, 0. And then love.graphics.circle fill. And then what we're going to do is we're going to find the bullet X, and we're going to find the bullet Y, which we don't have yet, but that's fine. And then we're going to do 5. So it's going to be a radius of 5. So it's going to be the same size as that little circle on the front of it. And now, outside of draw, is that the problem? No, that wasn't the problem. So, outside of draw, we're going to add love.keyPressed key and if key is equal to S, then end table.insert bullets x equals ship x, y equals ship y, and end. Okay, let's make sure that's right. So what I'm doing when I'm saying let's make sure that's right, if you scroll all the way down to the end, it'll give you the final code. So I'm just making sure. Well, where the heck did you put left key pressed? I'm just making sure that where I have it is where it actually wants, because it's showing it to me in a weird place that I don't believe it. So, you know. Okay, so it looks like that's a place for now. It's not where it's going to end up at, which is literally what I thought. Okay. So now we should have a bullet. And again, spelling will get me every time, guys. Spelling will get me every time. This is another reason why you want to test pretty regularly to make sure that things are happening like you want them to. So technically it's not breaking, but it's also not working. Which, yeah, confuses me a little bit, but when the S key is pressed, it's created at the position of the ship and added to the bullet table. It's not right. For end, for end, end. Okay, let's actually go ahead and put this just inside here anyways. Let's see if I break everything. Because there's a good chance I'm about to. So the problem with this tutorial is that it doesn't always tell you where things are supposed to go. So it is registering that I'm pressing a key code, but it's not registering that anything is happening. So that's what the key you just pressed is not recognized. It is recognized, it's just, yeah. So, something funky's happening here. Something funky in general is happening with this tutorial. Okay, so instead of doing this, let's look at the final code and make sure that it actually works. Let's do that first. So what I'm doing is I'm copying their code from their webpage. And then we're going to walk through it, because that may be easier. Okay, so it does work in the end, but and you can see how all of our bullets are going places and doing things. And how it's resetting and doing what it's supposed to do. So let's walk through the final code rather than stumbling through the whole tutorial. 100% if this is what you're wanting to make, then go through the whole tutorial, but even then, I'm gonna say that there's probably better tutorials out there, and I will look through better tutorials and find some. This was one that I haven't actually tried yet, so it's a little weird to me, like how the googly eye one is set out really nicely. This one is not set out as nicely. So what it tries to do and what it set up to do, we were actually not that far away from ending. I don't know what was happening with that whole origin thing. And it may just be that I didn't follow, so generally if you were following along, they highlight things in yellow for the things that are new. And then we suddenly no longer have highlighting and things like that, or like I follow the highlighting and then there's something else that's changed, and yeah. It's a long day. So what we would have done, I'm just gonna walk through it this way. Basically what this says is wrapping the ship, which is what we talked about and what we were trying to do, and it just was not doing its thing. Well, wrapping the ship we had fine with. That was the idea, that when we went off one edge, we came on the other. And that worked great. What didn't work great was this, which is, I don't know why. To be entirely honest, I can't tell you why. Like, this should work perfectly fine the way that I wrote it, because it was written exactly like this, but we know that this isn't all that's in draw. So the question is, where's the rest of it? And where was it supposed to be put? Which may have been what caused all the problem, and you just have to be careful with those kinds of things. It's also one of the reasons why I tend to like video tutorials better, because they tend to walk you through things a little bit easier, and even if they don't, you can kind of stop and say, okay, that's where that needs to go. If things had gone right, it would have done this. Instead of, what it did was, and when we look at the origins, what it was doing with that whole origin code or that translate code was the origin that it was taking was here, this top corner, and it was moving it by 1 to the left. So basically, if you think of a big kind of grid, instead of it being at that 0, 0, it was at -1, -1. So if you're talking like UV maps, that's what it was doing. So because that didn't work, this didn't work, which meant that other things didn't work. And yeah. So what this would have done, function load, we would have had all the load code, the bullets at the end. Sorry to interrupt. Error. Main 5. Point. Graphics. Point. Call field point. a nil value. So it may be because, let's look and see. Love may have finally gotten rid of point as a singular thing. Love2d.org. So let's see if that's how it is. It may be that you just can't use it that way anymore. Love dot image. No. Love dot point. Let's just try. Love dot graphics to draw. Okay, so synopsis. Draw, functions available. Draw. Point. That's not what I want. Love.graphics.point. Search. We can search faster than this. I know we can. Okay. Wow, what's your problem? Come on. Aha, okay. So, the reason why it's causing problems with love.draw.point is apparently it's been removed. So you have to use the points version rather than point. So, instead of using love.graphics.point, you're going to come over to this one that says love.graphics.points with an S. And as soon as it loads, you're just going to do love.graphics. So basically, as long as you just put an S, you should be fine. So that should fix that for you. Okay, so the bullets are stored in a table, and then what happens is that they're drawn in an index and pairs, and so basically it's like, hey, for every bullet that currently exists, keep drawing them at these places that they are. And then this separate function, it sort of works like the way that we were looking at the way that we use the arrow keys to rotate and move. But it uses kind of a slightly different key press kind of thing if key equals S. Is one better than the other? Not really. It kind of depends on what you're using them for. Excuse me. To be entirely honest, this is nice, but it's often harder to remember than saying the ones up here if love.keyboard is down. Like that's pretty easy. The big difference is that key pressed means that it has to be like, if I remember right, it doesn't like continuously fire. So creating bullets at the edge of the ship. So this is just saying, hey, instead of creating them like smack at the center, push it out. And you do that by creating a radius and then telling it to like go outside of the radius. So moving the bullets. The logic behind this literally is the same as every other logic. Yeah, you do your cosine and your sine to get it to move, and you use your angle. So bullet time left. So this is the idea that you have a timer on your bullets. And it sets it to 4. It does the same thing. Hey, we've got this time. If the time is less than 0, remove it from the table. And so when it's removed from the table, it's removed from existence. Again, if this is confusing, if this idea of like removing things from a table, don't worry about it. You shouldn't have so many bullets that it's going to crash your system unless you're like literally spamming bullets every half a second. But yeah, basically the way to remove it is you remove it from the list and then it no longer gets drawn. So life is good. Yeah, cool. So points with an S works. I will make sure to message that out. I'll do that right now. Okay, so back to this. So basically, all this says is, hey, here's a timer on the bullets. If they're still alive after I count to 4, then delete them. Or if I count down from 4, delete them. And that's kind of cool. It's an easy way to do that. You're not having to like actually access your OS time or anything like that to go crazy. You're just counting down. And again, you make a bullet timer. You do use do T. You do use, hey, do this whole thing here. But, And see here, I told you it was going to get removed. That was in a bad place and a stupid thing. So they removed love.keypress. And they put in this kind of bullet timer kind of setup. And, yeah. So now, when you draw the asteroids are going to work the same way as everything else when it comes to drawing. What the asteroids are that makes them different is the fact that they have to be made smaller. And you have to make multiples of them. So what it does is it creates a table of pairs, a table of tables, technically. So this is a table, and then this is a table, and this is a table, and this is a table. So, and you can nest tables inside of tables, inside of tables, inside of tables. It just depends on how you want to do it. But each of these controls, pairs. And we could do it where we do the index and the thing, but then you have a problem accessing the index value, and it just gets messy. So, a table of tables. And these control, the different aspects of your asteroids. And then we just tell it to, hey, take these pairs, take these things that we're talking about, and do the thing with them. So then we draw our big asteroids. And we start with 3. We only ever have 3 going at any given time. Until we break them into smaller things. So now we have to move them into random. Now, warning. Can you see a problem with the fact that we're just using math.random here? Love tries to make math.random a little bit better. And if we come into their wiki, we can see if we do love.math.random and we search for it, you can click here and it's going to say a pseudo-random number. Remember, we talked about this. These numbers maybe are going to be the same every time, so maybe you don't want that. Maybe you want to seed it. You can seed the same way. You should be able to seed the same way. So, there's new random generators. There's set random seed. So yeah, you can mess with that to make it more random. Or you can just not care. Because sometimes pattern is the spice of life. Which sounds counterintuitive, but it is. So we draw the asteroids and we get them going and we get them doing our thing. So next we have to say, hey, what happens if this intersects with this? And you can see this requires a lot of math. And all this is a single statement function. And what it takes is it takes AX, it takes AY, it takes A radius. So it takes the first circle's X and Y and their radius. And then it takes the second circle, BX, BY, and its radius. And then it looks to see, hey, have we hit each other? And returns whether it has hit each other or not. Whether it's true or false. And if the circles are intersecting, so if ship X has hit any of the asteroids in the asteroid table, then everything breaks and you reset everything. So when it comes to drawing, we now have our asteroid radius. And so that's all that is. We're just switching this around so that we're using actual variables instead of hard-coding numbers. Again, bullets colliding with asteroids, literally, it works the same way. It works the same way as the way that the ship did. You just apply it to a different index, and life is good. And I'm not saying life is good, but I'm saying life is good. So, asteroids is definitely, especially written this way, is a complicated and convoluted way to do all this. It doesn't have to be this extreme. Don't get me wrong, this is probably relatively easy if it worked correctly and I wasn't tired and on like 2 hours of sleep. But yeah, so we look at our asteroid. Remember that this gets the length of the table. The hash sign, pound sign, number sign, tic-tac-toe thing, whatever you want to call it. If you put that in front of the name of a table, it gets the size of it. It gets how long it is. So, and unlike with other languages where you have to do like -1, or add 1 or anything like that, because Lua starts at 1, you don't have to do any funky math. That just gets you the actual length. So, and again, we're just switching out bullet radius because we know it's a stable thing. We can switch it out to a variable so that, like, up here, it's a variable now. Breaking the asteroids is where things get really complicated, because those of you who have played with anything that causes destruction, as far as, especially if you've done anything in like the 3D particles and dynamics and things like that, those get incredibly complex because you do much more math. So when it comes to this, again, they're not thinking in a realistic term, they're just thinking in throw it in a random direction. So they're just using love.math.random. And they're just using take that angle and do it with pi. So the stages. Again, this is saying, hey, these are the different stages. This is how they work. This is the speed, this is the radius, this is the speed, this is the radius, this is the speed, this is the radius. And so these are technically kind of pairs. Yeah. So in this stage, we remove the radius of them because we now need them to be multiple different radiuses, which is what all that sets up. So, and then we say, hey, look and see what stage our asteroid is in. So we've created a stage. So asteroid.stage equals asteroid stages, you know. We can look and see what each of these are. And then we can apply it and make sure that it's working like it's supposed to with these new variables that we've created. So game over. If asteroids equals 0, so if there are no asteroids in the list, then the game is over. But we also had earlier, if you collide with it, the game is over. Insofar as the game isn't over, the game just resets. But it hasn't reset yet. So to reset the game is this long kind of thing. And all you really need to worry about is this one right here that says function reset. So this is written insofar as this is what controls a reset. So ships, basically all this does is it resets everything back to the starting position, it resets all of the happiness, and then lets you go at it again. And so then you just call reset where you need to call it. So if asteroids equals 0 or if there's a collision with the ship. And that's kind of how this works. They've got the final code for you. Again, I was going to walk through this. I really, really was. But I am hungry and tired. And I can, if you guys want me to, go over it again and make sure that it works this time. Because I don't know. It may have been that it would work better later down the line. But for whatever reason, I was having issues. And it may, it could be my fault. It could be the direction's fault. I will 100% probably go through Snake and at least one of the other ones, maybe the Match 15 one, and record those for you guys for next week. Yeah. But yeah, food is good. But I did want to, so these tutorials, they do tend to be good. This is one of the ones I always look at it and look at how much math it has, and I'm just like, I'll go do one of the other ones. And I like math. That's the biggest thing. That's the most hilarious thing to me, is that I really enjoy math. But this, I look at it and it's just hard. But, and again, I had somebody have problems with Flappy Bird. I haven't actually gone through Flappy Bird. Blackjack is pretty easy. You do have to get the pack for that. Blocks is nice. Again, if you want to make a Tetris or a match 3 game, this is a great place to start. 15 is a slider puzzle. Slider puzzles are cool. You want to make a slider puzzle out of images or want to make something that works kind of like a slider puzzle, this is a great place to start. Flowers, I have never heard this game called Flowers in my life. It's Minesweeper. Life is weird. We're just gonna go with that. Repeat is this idea of, it's a Simon Says type of thing. Snake is Snake. Everybody loves Snake. And Sokoban is kind of a weird, basically you push all the boxes into the corners that they need to be in. I would say that it was like the box game on graphing calculators, but again, I don't know how old all of y'all are, so I don't know if that reference is actually a thing. Yeah. Back in my day, we did have graphing calculators. But in my day, graphing calculators had this little game where you played as like a delivery dude and you pushed blocks around. And yeah. Yeah, we had professors that tried to ban, or teachers that tried to ban it in high school. They're like, you can't have your graphing calculators out because we know you're playing games. The answer was we were. But, yeah. So I'll walk through 2 of them at least. And I'll record them for you guys. You can watch them if you want to or not if you don't. Look for tutorials. There's all sorts of tutorials all over YouTube. If we come to YouTube, y'all are gonna see a whole bunch of horror stuff on my front page. That's fine. And we look for Love 2D tutorial. You're gonna see that there's a bunch of them on here, and it just kind of like whatever you're wanting to do. If you're wanting to do a platformer, go right ahead. If you're wanting to do a tile game, go ahead. If you're wanting to do, yeah. So you're gonna see a lot of these things, but you're also, I've given you all the code that I have. You can also look at game jams and see how people made things, and then this workshop will be introduced a game called blah 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 blah. Is this the one that I like? No, this is a different one. So this is kind of a shooting game. This one's fun. I know which one this one is now, but do you actually end up demoing your game? I don't remember. Somewhere near the end, yeah. So. No? Okay, there. So this one's kind of cute, and it's a great... Are you going to play your game or are you not going to play your game? You're not going to play your game. Okay, so, but this is another one that's a good one to look at if it's something that you want to do. That'll show you how to actually package it if you want to package it. So, yeah. Make an easy game. I'm literally not asking you to make something hard. Please, it's not a trick question. It's not a me trying to get you to do the least amount of work and then get mad at you. No, I do mean something easy. Make a clicker game. Make like the fish game I made is perfectly something acceptable. I've given you guys the links to my REPL. Any of the REPLs that I have, or any of the REPLs that you go to that just say like PSipes blah 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 blah, if you click my name, PSipes, it will open up all of my other REPLs. It'll open everything up. So you can actually come in here and say, I kind of want to do something like this fish tank. So let me do something like this fish tank. And I will say one of the things that I really do like about this fish tank is that it randomizes the tiles in the background. I know that is such a tiny thing, but it changes the way that the tiles work. So yeah, they're all using the same tile sets, but it changes which ones go kind of where. Insofar as sometimes you have shells on one piece and sometimes you have shells on another piece. So if it will run, I can show you. So pay attention to the fact that we've got the purple thing there and the green thing there, and we've got 3 shells right here. It also randomizes the fish. 100% y'all are free. This one's not commented well, but ask me questions if you have questions. I am here for that. But see, so now we don't have that like 3. We've got like a bunch of these guys. We've got a different purple thing. We've got orange things. And then there's different kinds of fish floating across the screen. So 100% these, you can use them if you want to use them as bases, or if you want to see like how they work. Clicker games are fun. Clicker games are easy. So with that said, I'm going to go ahead and let us go. I'm sorry I didn't like actually walk through the tutorial. Like I said, I'm hungry and tired. So I will talk to y'all not next week, but in 2 weeks. And I will put up assignments that's going to like check on where you are in your games, what problems you're having. There'll be discussion boards, so they'll be simple. Yeah. So I'll see you guys in 2 weeks. Yeah. Bye.